In this video, we will be building this game where you are going to learn all about creating a 3D stealth game where you will create the towers, you will create the AI of the enemy where it has 3 states. You will learn about for loops, if statements, you will learn about layer masks, animation players, and so many other systems. And you will create a more complicated game controller that sort of gives you a small quest for this level. You will also learn about using multiple detectors when creating the player. You will also make sure that the player can only be seen at an angle. So if you are behind the enemy, then the enemy is not going to see you unless you are spotted by a guard tower. We are going to learn all of that and more inside of this full course where you will create your very first Godot 4 game. Whether you have used other engines previously or this is the very first engine you have used, then this video is for you. If you like what I do and you would like to support me, all you need to do is wishlist Amira on Steam, which is a game that I have been building for 7 years. And you can also subscribe and like the video if you like it. So let's begin. Hello and welcome back everyone. For this video we will be creating a stealth based game in 3D. You will create some towers, you will create some AI that patrols the area and towers that detect the player. You will explore things like, you will explore some more advanced concepts, especially in 3D, and like the rotations because they are handled very differently than in 2D, and many other things. So if you are new, you can continue watching this video, but if you find that you are getting lost so much, just watch our previous video where we explored the 2D world, where we explored like the editor in details. We created a ball game, and you explored like scenes which are like prefabs. You created a level, you restart the level when the game is over, and so many other cool things. Let's begin now first by importing the models that we are going to use. First, this is the asset kit that we will use, and all you need to do is just go to this link, which will be in the description, download the zip file, which is a compressed file, and then you can donate for Kenny. He's he created so many assets for free for everyone to use, and yeah, he's very good. So yeah, donate for him if you like the works. So I already downloaded this asset pack, which is provided by Kenny, and it's already actually in the project. But let's begin by, let's see, this is a new project, and let's begin by the importing process in case you haven't watched the last video and you don't know how. It's actually very simple. So first things first, you just right click, new folder, you give it any name. I'm going to call it AA models _2. Then you can come here and you will see, as usual, we will import these 3, which is the sample, just on the preview, it just shows us what we have, and the license, which is like the license and the links that are related for the kit. Then you have side, which is just PNGs, isometric, also PNGs, which are pictures, and we don't need that, we need 3D, which is models. And here we have inside of models, we have like multiple extensions. So for our case, we will use the DAE format. So Kenny provided us with so many, as you can see, he provided us with so many like extensions that you can use, and like for example, a 3D modeler in his 3D modeling software, whether it's Maya or Blender, like he can export in multiple formats. And Kenny exported in many formats so that anyone can use them. And for this particular pack, the DAE format, I found that it works best inside of Godot for this particular pack. For other packs, things might be different. Like, but what does it depend on? Does this mean that FBX is not going to work? Like, no, it actually works. GLTF, same thing. But for this case, they have different. But for this case, they have like, they have wrong pivots, or like they are offsetted, or they have wrong facing, and so on. This is like, for example, the 3D artist, when he's making the models, he can like, for example, he knows what are the needs that Godot has, and he can export with that mindset. And so when he imports, when they are imported into the Godot project, they just work. For him, he provided us with so many extensions, and this one works directly out of the box without any modifications. Now, can you use the OBJ? Yeah, you can. It might have like wrong facing, and you can fix that on your own. Even inside of the Godot editor, you may not need to go to 3D modeling software to fix it. But why should we trouble ourselves? Let's just use the extension that works. Now, if we go back, you can see it will start importing. Now, as I said previously, I already imported the models. They are here in this directory, but I just wanted to go through the import process. And here they are. Now, if you come here, you can see it has like so many models that you can use and so on. Now, for me, I'm going to delete this directory because I already actually have the models. They are here. Here's the DAE format. Okay, good. So let's begin now by creating our 3D game. On the left side, as you can see, we have 2D, like in here, we have the file system, which is where our files would exist. I should have probably explained that previously, but yeah, you can figure it out. Yeah, so and on the top, we can create anything we want. We are creating a 3D world, so let's just create a 3D scene. Let's call it level_01. Let's do save scene, and also it's called level_01. Let's save it. Here is our level now. Now let's begin by dragging our very first model into the view. Now if you expand, and then let's just grab the astronaut B. There we go. Now as you can see, we have a model inside of the game. Let's think about navigation. If you click up and like right click and then move the mouse, you will see that you can move the camera, like you can move the view. If you right click and then click WASD, you will see that you can move. If you scroll back or scroll in, you can get closer or further away. Okay, good. So we have our first model. Let's now start by creating some terrain, some floor for the player to walk in. So let's just add it. By the way, our player is going to be a ship, so we will remove this guy in a bit. So here is our terrain, and it's just some square, a small square. You can have a ramp if you want, or whatever you want, but we don't want that. Let's just stick to the normal floor. Now you can see, if I have this selected, I can move. Now you can see I can put them like close, but it's hard to put like the models on top of each other. And if I Ctrl D, I try to put it like this, like you can see, it's somewhat hard, and they might be like, there might be some distance between them. So yeah, that's not very good. So how can we fix it? It's actually very easy inside of Godot. So you delete this, you come here to the magnet, click on the magnet, go to the floor, click Ctrl D, and there you go. Now it just snaps automatically on its own, and that's fantastic. You can click like on one object and then click shift and then select the second one, then let go of shift, then Ctrl D, and there you go. Now we have a square that we can look at. That's very good. Let's just try starting the game and see what we have. It tells us we don't have like a starting level for our game, so let's just select the current, and there we go. The game started, but we see nothing. Why is that? Well, it's actually because when you are working in 3D, you always need a camera. In 2D, you have this square, which is like the purple, orange thing, colored thing, and yeah, it might be hard to see, but here it is. It's this square. You have this square, and you can see in it like directly. But in here, we need a camera. So let's right click, add a child. Of course, not camera 3D. We need camera 2D. I mean, we need camera 3D, not camera 2D. So let's click, and we see something. We can see something. That's fine. Let's move it back. Okay, so we can see our model. That's good. Let's just move it a little bit up. Let's move it a little bit back. Click play again. Still a bit difficult to see, but it's progress. It's progress. Now you can see our hierarchy got cluttered. So let's just organize things. Let's create a new node. Let's call it environment, and place everything that we have inside of here. Let's just click play again, and yeah, there it is, like nothing changed. Let's just try clicking the mouse, and then rotating down. You can see we can rotate. Of course, you can come here and you can change the rotation by your hand. Let's just like this. Okay, we can see our model now. That's fantastic. I will give it like a space of 6 maybe, and there it is, far above in the sky. And there it is, like far above in the sky. And let's click play. Here the player is looking very far, and that's fine, but we can see like there is a difference. It's very dark. Why is that? Let's fix it. Click on the three dots, add environment. Click on the three dots, add sun to the scene. Now, click play. There you go. Now you can see the view. I'm actually going to do something very fun. So I'm going to move the camera back. So instead of 6, I'm going to move it to -6. Now if I click play, I will see nothing, but I will rotate it 180 degrees. Click play. There you go. Now I can see the back of the player. So I'm going to go to the astronaut, go to his transform. On the right side, we always modify properties on the right side. I'm going to give him 180 degrees. And there you go. Now you can see his face. Let's click play. Okay, good. But sure, we can see his face and all of that good stuff. But it's very hard. Like, it's somewhat cumbersome to click play, move the camera a little bit, click play, and so on. How can we fix that? Click view. You would click view, 2 viewports. Now we have 2 sides. Now, if you click the camera, click preview, now you only see the things that the player can see. And on the other hand, you can now modify the scene or the level or whatever in here. Let's say maybe we want to have, I don't know, I'm not sure. Oh, I definitely don't want to move that. Let's say I want to maybe find some satellite. Do we have a satellite? Yes, we have a satellite dish. Okay, it tells me, like, it gave me an error because I had multiple nodes selected. I only need to have one selected. So here it is. Now, here we go. We have our satellite dish. Like, we have another satellite dish maybe. Let's click play. We can see them. That's fine. But that's not what we wanted. What we wanted is, like, yeah, to see the camera clearly, and we can see the camera clearly, and that's very good. We let's remember, like, it was very dark. When it was very dark, when we didn't have these, click play again, back to dark again. So let's fix it again. Add the sun, add the environment, and it's working. Let's just click on the sun, which is the directional light 3D. Let's select the light. As you can see, we can increase the energy, and it's looking brighter and brighter and brighter, and it's now very bright. I like usually just using like 1.25, something like that. So it's just a little bit extra bright. You can also change the color and choose whatever you want. So let's go with this color, make it maybe alien type of thing, environment, with purple and stuff. Okay, but it's still like, it's still not that good. So let's improve it a little bit more. So we will click on the world environment, go to environment, go to the sky, open the sky, open the procedural sky, and now we have a ground and we have the ground and like the sky. Let's see the ground. The ground is very dark for sure. Let's just make it a little bit brighter. Yeah, it is now brighter. Let's now select some other color. We said we want it to be some sort of alien thing. So yeah, this works. We can also increase the energy multiplier, which will make everything brighter. Let's make everything a little bit more bright. Let's put this one to 1.5. Yes, things are very bright right now, and that's fine. Let's see now what we have. That's very good. So if we click play, yeah, things are still a little bit better, but like it's still looking very small, still looking very far. How can we fix it? If you scroll up and click the, make sure this one is selected, you can just go through the camera and push it closer, or you can come and change one of the other properties, which is called FOV. I usually like to keep this one as 50 or 55, but let's go with 50 because why not? And there you go. Now it's much closer and it's much neater and easier to see. And you can actually just change it here, come back here, and it's very close. That's how you would do zooming. But yeah, let's go with 50. Let's do this. So let's just hit play. And now we have our level. Okay, good. That's fun. That's fantastic. And let's remember, what is our game? In our game, we will have a ship that moves around, and we have some guard enemy ships, which are like enemy ships that we need to avoid because we cannot attack or do anything. And yeah, so we don't need a human, sadly. What we actually need is, let's make sure the mouse is selected and click the human and just delete him. Let's see the models. Do we have a ship? I think we do have a bunch of ships, like I already checked them out. Oh, you also have a hangar, which you can also use and stuff. A barrel. And by the way, from here on out, it's just level design. You need to design the level that you actually like. Oh, there's also a meteor. So yeah, a lot of models. Just drag them and drop them. Explore the toolkits that you have and just place models next to each other, and that's really it. Just keep like duplicating and placing models next to each other in a way that seems cool looking. And yeah, we wanted to find the ship at the very least. I think it was called cargo craft. Yeah, there is my ship. Oh, but the ship is very large. I want to make the ship smaller. How can I do that? Very easy. You go to transform, scale, make it 0.5. Now the ship is smaller. So that's our player. Okay, so let's see. Before we move on to designing our own level, let's say we want to give our player some custom colors. How can, or maybe not the player, let's say this one, let's say this hangar. How can we give it some custom colors? It's actually very simple. So you go to the, it's called round glass 2, round glass, there it is. Double click on it, it will open this window. It has so many settings. What we don't really care about any of them. We only care about the actions, extract materials, and you just create some new folder and call it, let's see, what are we going to call it? And let's just click OK. So we have this folder. Let's select folder. It will extract some files. Let's just extract the files. Let's just close them. Now if we click on this one, now if you can see, we have our new directory called hangar materials. If you come here to the materials and let's say, what is it that I want to change? I want to change this thing. So yeah, this yellow, it's called red, but yeah, it looks like yellow to me. So I'm going to take this yellow thing and just go double click on it. You can see it has many properties. So albedo, see, it's now white. And let's just give it like this. Now it's blue. And let's see, now it's pink, green. You can choose, by the way, you can see it's changed in here as well. So let's focus real quickly. Yeah, it changes in both ways. And that's how you would simply, give everything a unique color or some unique property and or a unique texture and so on. Now you will note in my project, I already had a directory called levels. Why is that? Well, because off screen, I already had designed the level that we want to build our game on. And let's double click on it. And this is the level that I'm going to use as our target goal. So let's just explore it really quickly. Of course, like the project files will be available to download in the description. So you don't have to worry about it. If you want to work like step by step with me, just download this level and yeah, do whatever you want with it. Now I will take level 01 and stick to working inside of level _00. So let's just move forward. Now you can see we have the gate, which is where it wants, like, which is where our ship should go. And you can see we have these rocks, and these are the terminals which contains the keys that we need to collect. And there they are. And of course we have the sun, the lighting, the camera, and everything. Let's just click play. Oh, it moved us back to the wrong level. Let's see how can we actually update that. It's very easy. You go to project settings, and then you see in here we have general, run, and we have the main scene. The main scene is not level 01, it's level 00 now. And there is our ship and camera and player, and everything is already set up for us. So let's see what are we going to do. First, this is our ship and this is the enemy ship, so they look very similar. I'm going to change the colors of the player ship, and yeah, that's the ship that I selected for the player. By the way, I heavily recommend that if you are starting out, you do everything by your own hand. So like, try to design your own neat small level. It's literally just like you can see in here, I have a pipe. I just moved it and copied it and like duplicated across the level, and that's it. So it's not really that hard. Just keep duplicating objects, create your own level, and that's all you need. Now, of course, you can use the level that I made and then create your own level, and that's also fine. But yeah, I'm only going to work on one level, and the level 01, it's yours to make. So let's change the color of this ship. So, oh, I selected the terrain. We don't want that. It's called Craft Speeder D. Craft Speeder D. There it is. I double click, actions, extract materials, create new folder. It's called Craft Speeder D. Create, select, extract, and just close. Now, if I go to this folder or directory, let's see, what do I want to change? I want to make this yellow thing, which they also called red again, as I'm going to make it green. Let's go green. Okay, that's fine. That's a very hard green, so let's make it like this. We can also give it some emission, which will make it like a stronger green. There we go. Now, if we double click in here, we have another property, and that's fine. Let's just go to the albedo and let's see green. So I'm going to pick purple or orange. Yeah, there it is. I'm liking this ship far more, and it's looking very different than the enemy's ship, so that's good enough for us. So let's just save now, and let's begin by something we did in the past, which is creating our player. First, let's look at the model. This is the model. Like, we used a sprite in the past. We don't need a sprite in here. We just need the model. So we drag and drop the model. So this is like our sprite. Let's check out our sprite. It's the craft, it's the ship, and it has scale of 0.5, and you can do whatever you want. Now I'm going to come here, click the plus icon. Now, if you remember in the past, we went here, here, here in the previous video, which is linked in the description, and we selected character body 2D. But of course, this one will be wrong today. Like, no matter how hard you try, it's not going to work with that. So you need to go to 3D, physics, and character body 3D. Why did I choose character body 3D? Because it's the simplest to make work. And yeah. And so here it is. So you can see this is where it is, and this is where our ship is. Let's remember, this is where our character body, which is the player, and this is where the ship. What should we do? We should always put the model or sprite inside. Then we need to always make sure the position is 0 and position is 0, so that they are on top of each other. Now we can select the root, which we will call layer ship A, for example, and we can just move it forward a little bit. And now let's just click play, and here is our cool ship. But it needs to fix the error. How can we fix it? Well, just like we did in the previous video. So you come here, you add collision shape 2D, and it should, oh, a mistake. There you go. And you can see now Godot is telling us there are two problems, and the core problem, like, we already know what's the problem, like collision shape 2D, and we are in 3D world, so that doesn't work. So plus, and we need collision shape 3D, and it has no shape. How can we create a shape for it? Very simple as well. A box shape, and I think that's good enough. That's a good collider for the model that we have. Now all we need to do is just to make our player move. So let's just create a new directory, call it scripts, click the plus, player ship A. Let's remember player ship. Actually, no, yeah, let's call it player ship. That's it. Let's call it like this. So where are we going to save it? Of course not inside of levels. We will save it inside of scripts. So create, and there we go. We already have that same exact script. And there we go. We already have that same exact script. Like, you will see so many similarities between this and the 2D variant. Let's just click play. The ship fell down. That's understandable. So what is it that we need to do now? What we need to do is just get rid of the jump velocity and the gravity like we did previously. So let's just remove this, and we have no need for gravity or jump velocity. So let's just remove this as well. Let's just save now, and let's see, can we move? Oh good, we move, but we don't collide or hit anything. Now that's quite problematic. So Well, there is actually two ways to fix this problem. We need collisions. So if you now click on the wall and click on this icon, it will tell you that you either need to use new inherited or open anyway. Like, let's just open anyway and see what we have. If we click the plus and try to add a static body 3D and then add another shape cast, but like a collision shape 3D. Let's make it a box. There we go. We have some collider. Now, if you try to come here and save, you'll see you have the dot and you have an error. Oh, now that's very interesting. Oh, and even if you do it like this, like, yeah, even if you fix it and you try to save, it's not going to work. It will always show an error because we are inside of the model, of the model itself, and we can't edit the model itself because it's just some file exported from maybe Blender or 3D Max or Maya or something like that, and that's not something we can change inside of Godot. So instead, even if you do this save and close, it's not going to work. So, and you can see in here it's telling you like changes may be lost, so don't save. Now let's go back. So how can we fix this problem? There are actually two ways to fix it. So let's see. The first way would be to click on the plus icon, use the new inherited. Now you can click the plus icon. You can add the collision shape. You can also add the static body 3D, but they need to be in the other order. There they are. Now we just need to give it a shape. Let's see, where is the shape now? Here is a box shape. Let's add the shape. Let's just remember, move the handles. Do not change the scale ever. Like the scale should be 1, 1, 1. But this, the size can be changed safely. So let's say 0.5, 0.5. That's actually pretty good. Let's actually just make it a little bit bigger. So 0.8, 0.67. Yeah, that's almost fitting. So I guess it's 0.7. There we go. Now, if you click here, click save. Now you need to create a new folder and call it, not prefabs, we will call it scenes. And finally, you will save the pipe straight. Now, if you save this pipe and then you close, and now if you go to scenes, and now if you drag this and drop it, you will see it has a box around it. If you move it here, it has a box around it. Let's just see it in action. So I'm going to save and close in here, and I'm going to come here and just do this. And let me just select this one. Like I'm going to rotate it by selecting this green thing. Now if we click play and move, you can see we can hit and collide with this one, but we can't hit and collide with these. So yes, in this case, this is actually one of the most common errors that you will face throughout the development cycle, like as a beginner at least. And it's that there is a difference between when you drag and drop a model and when you drag and drop a prefab or drag and drop a scene in this case. So when you drag and drop the model itself, you can't change the model at all. But when you drag and drop a scene like we did, so what we did was as follows. We went to some model, we dragged it and dropped it, and then we clicked on the plus icon and chose new inherited. Now we can have a scene. Now you can add maybe some UI above it. Maybe you can add some let's explore the UI thing later. Maybe you want to add some, let's say, I don't know, as we said, static body or the collision shape maybe, or whatever it is, or some particles or something like that. You can add whatever you want. Then you would save it and you would get a scene, and that would work. Now, why did it work for our player but it's not working for our model, like for our walls? What we did for the player was we took the model. Let's just do a copy maybe, and let's just do Ctrl V to paste it, and here it is. So we took the model and we clicked the plus and we chose the character body and we put the model inside of the character body, so it works. So we are not modifying the model. Instead, we are putting the model inside of some scene, and now we can actually easily save it. So let's just click the right click and save branch as scene, player ship A, put it in scenes, save. That's it. Now the player is a scene actually, and this is this pipe we can collide with it, but for that pipe we can't. So now you have two options. Now you can just go through each and every pipe, or like each and every place where we use this scene, and replace it throughout the entire level. And if you already built 10 levels, now that's going to be because that would be a very big problem. But there is actually, even if you made this mistake, which I should have guided you about it before, but it's learning by doing. So you needed to make the mistake. You needed to realize what's wrong. Otherwise, it would have been more theory and yeah. So now you can see the problem with your own eyes. We need to just replace all of these. So I need to come here, delete this, and put them, and come here and just put them like this, and then duplicate and put it like this. Yeah, it's going to take so much time, and that's not something I want to do. So what if we have some alternative way? This is actually a very easy way that many people use. It's very easy. Do this very small hack. So first you would create the static body, then you would create collision shape 3D, then you would give it the shape. Let's see. So box collider. Okay, good. Now what you would do is as follows. Let's just drag it and drop it in here. Here it is. I just moved it here. And then you would come to the shape. Don't change the scale. Again, if you change the scales, then collisions will break. You should never change the scales. Then you would just come here and just do this. There you go. Now you have a collision to the left side. Now you have a collision to this left side. Now, as I said, this will work. It will give the same result. But this is a hack. This is not the proper way to do it. The proper way is you would create a new scene for each, like we did in here. You would create a new scene, and you would use the scene that has the collisions and has the properties and has whatever it is that you need and want. I'm going to really quickly now just let's do this one before I speed up the video. Let's do this side. So I do Ctrl D, duplicate. I would just do it like this and do this on the transform, and there we go. Now play. This work. Now these three sides work perfectly. So yeah, nothing to worry about. Now of course you can create a new node 3D and call it. It should be an empty, so it just holds the collisions, and it can call it collisions environment collisions. This name works, and you would just include all your environment collisions inside of this one. So yeah, that's it. And now let's just go ahead and start duplicating, and yeah, I'm just going to speed this video up. Remember, you can change the rotation, you can change the position, but you cannot change the scale. You shouldn't change the scale. Now, before I continue with the level design, you will note something very funny. If you go to one of the static bodies and you change the shape, you will realize that all bodies that you duplicated will go smaller and bigger as well. And that might not be something you want, or it may be something you want, I don't know. But yeah, it will affect them all. Now, let's say you want, for example, I have this area, and this collider would be very large for it. So how can I fix this problem? Well, it's really simple. You just duplicate, you move this one to the side a little bit, and then you come to the shape, you click here, you use make unique. Now, if you click this, if you make it smaller or bigger, it doesn't affect anyone else. So let's just do this. But when you actually have the time, you should go through every model that you have. Then you should go click on it, then use new inherited. Then you would create the collisions in here. Now that would work. That would be the best solution. But for the times where you just don't feel like it, and you can just use this trick that I just showed you. Okay, now let's just play and see. We can move. That's perfect. Let's get some camera movement, because if the player just keeps moving, like, yeah, he goes out of view really quickly. So how can we make the camera follow the player? By the way, the camera should have this current thing. In any case, let's just pick this, do this, start the game, move. Oh, that was actually very, very easy, as you saw. Oh, I guess the collisions in here are somewhat bad, and yeah, that's the issue with this hack that I mentioned. Like, you need, overall, it might be, it might be more time consuming to just fit collisions for every single level. So that's why you shouldn't use this method for every single level. Say you have 100 levels, that just doesn't make sense. But instead, you would create, for example, the inherited scene, and you would reuse it in all levels. And since you reused it in all levels, then that's it. All levels would have the same collision and it would just work. However, for this one, let me just again fix it really quickly. So here is a static body. Here is a collision shape, and here is a small box. And now let's just move it for the place where we have this error. So let me just duplicate this one again, and yeah, now we should have some proper collisions. Now you can see this collision is also somewhat large. I'm not going to fret over it. I'm not going to change anything of this environment collisions after this. So let's just start the game. Now we can move and everything is working nicely. And of course, this one is a square, and that's bad. But if you actually created a single collision for each and every one of these rocks, the collision would be more accurate. And for example, you would be able to walk in here. Why? Because the collision of the rock is actually smaller, as you can see. But as I said, so I'm going to move this one to 0. I opened the player prefab. Now actually, why did I open the player prefab? Oh yeah, I shouldn't open the player prefab. We want rotation. We want the player to actually face where he is moving. How can we do that? You use a function called look at, and then you would do the following, like, where are we looking? Let's think about it for 1 second. Where are we looking? Where are we looking? Let's see. Let's go to 3D. Here we are. What does the function say? It says target, like the target we want to look at. Let's think, where are we going to look? So where is our ship? Here is our ship, for example. So where it is that we want to look? We want to look at this position, which is where the ship is at this moment, plus its movement speed. Let's say it is moving in this direction. So let's say it's moving in this direction. So like, this is the position of the ship, and this is where we want to look. If we are pressing forward, this is where we want to look. If we are pressing the W and the D key, this is where we want to look. So we want to look in the direction of the velocity. In the direction of the velocity. That's just fantastic. So how can we do that? Very simple. Again, the target, which is like where we are at the moment. So we would use transform.origin, which is where we are right now. Now it will try to look at its own position. Okay, let's click the plus velocity. Plus velocity. So basically, where we are moving, where we will look, we will move the model where we are moving plus the direction, like plus the velocity, which is where it will end up, where it will be. Okay, good. But let's think about it. What if the velocity is 0 and we are not moving? Let's think about it really quickly. Well, then we will get an error. It will try to look for the position of itself, and that's not something we want. So we only want We only want to look at a certain position when we are actually moving. So let's just hit play. Now, if we move forward, it's working. If we move backwards, yeah, things start going wrong really badly. Why is that? There is a very, it's really fun. Let's see. So let's think about what is it that we are moving. We're moving the entire model. Let's see what happens when we rotate the model. Let's see. So we are rotating the model. Let's see. Okay, it's rotating. So what's the problem? We'll take a very close look. What is inside the model? The camera. So the camera is inside of the model. So when we rotate, actually, so it's not inside of the model, it's inside of the entire scene. So when we rotate the entire scene, yeah, things go wrong. Like the camera would rotate with us, and that's not something we want. So what is it that we want? What we want is to rotate just the model. So we go inside of the scene. What is the model? This is the model. How can we access the model? Very simple. Again, drag, drop, hold Ctrl. There we go. Now we have the model. Let's see. So I will take this, then just put the model, dot, look at. Now only the model will look. Let's see. So let's just hit play. It's almost working. Again, like there is just a small tiny problem. So if I'm pressing down, yeah, you can see like it's just flipped in the wrong direction. Like if I press down, it looks up. If I press up, it looks down. So how can we fix this? Very easily. We come here, we create a node 3D. Let's just say this is displacer. It will only displace our model visuals. So let's call it model displacer. Now we can put the model inside of it, and we can change the rotation of the model. To be 0. Now let's see, what is it that we want to rotate? We don't want to rotate this. We want to rotate this, the model displacer. That's what we want to rotate right now. So let's just do this. Let's save. Let's see. If we move up, yeah, it's still wrong. But why is that? Let's think a little bit. Let's see now. Okay, let's try changing this one to 180. Let's go to the 3D scene. Now let's just look. 180. Yeah, there you go. You can see it's flipped now again. One more time. Let's just click play. Oh, now if we move, it's moving properly. Huh? See? Did you get what I just did? So let's think really closely of what is it that I just did. So we have our ship. This is like initially we tried to rotate this one, but the camera is inside of it, so it just doesn't work. Then we tried to move the craft directly, but the craft directly was facing the wrong direction. All the time. So what is it that we needed to do? We either needed to change our code, or we can apply this trick, which is called model displacer. So we keep the model displacer as 0, 0, 0 and 0, 0, 0 and 1, 1, 1. And then whatever we do with this model will not affect the model displacer. So we can flip the model maybe 90 degrees, and now when we rotate, it will rotate based on the 90-degree rotation. Apply a displacement. This will apply a displacement. So the model is the model has a rotation of 180, but this one has a rotation of 0 on the y-axis. Now when we rotate this one, it will just rotate like it will just rotate this one, and whatever we change in here is just a displacement. It's just a displacement based, it's just a displacement, so it's not affected. It doesn't change anything. This is called like a parent trick thing. So yeah, so we just play, and there we go. Our ship is moving and rotating, and maybe we want to add some shooting. I don't know. I'm not sure. But the ship is very slow for sure. So speed is 8. Start. It's much faster now. Let's now go ahead and start making sure these terminals do actually work and we can just collect the keys from them when we actually reach them, because currently even if we move the ship to the proper place, then let's see, nothing, absolutely nothing happens, and we can't actually see the pickup point. So let's start there. So let's just move it here, and now, oh, we probably need to move the player as well. So let's just move the player a little bit farther away. Okay, good. Now we have this. Let's just move it outside. Let's just collapse everything. So now what is this? This is actually our model. So what we should be doing is creating an inherited and stuff, or we can just area 3D. This is just the visuals. Then you would create shape, a collision shape 3D, and oh, we need the shape as well. Let's just use another box. Let's see. So where is our shape now? Oh, come on. There it is. Oh, but it's, see, that's the problem that happened, because I forgot to reset this to 0, 0, 0. There we go. Now it's 0, 0, 0. So let's just save branch as scenes. This is our key. And let's go inside of the key. Let's come here. Let's create the script and save it inside of the scripts directory, of course. So here is our key. Again, very, very, very similar to what we did when we picked up the coins. So I'm going to go through this really quickly. And if you don't know what we're doing, then like, you can just watch the previous video that we did. So we created this key. Now we need to go to the node, and now this key, when the ship intersects with it, it's going to scream, it's going to do something, like it will just print a message for now, of course. So let's see, how can we do that? So we have these signals, like if we go to node, select this, go inside of the key scene, and select this. Now basically this area 3D is just some node that will scream, that can scream based on certain events, when a body enters it, or when another area enters it, or when a body shape. Like, we don't care about the shapes, so these are to be excluded. Now we only care about when an area enters or when a body enters. What is the player? The player is a character body, so we need body entered, connect, and there we go. Now we need to make sure we actually connected. We need to make sure we actually connected with the player. We actually need to make sure it's connected with the player. So we need to go back to the player scene and give it a tag. So group, let's give it the player tag. So now our key will work only when we are if body.is in group of player print we detected the player. Very simple, very easy. So let's come here. Oh, it's actually not working. Now that's quite interesting. Let's just see what we have. So let's just try to print anything at all. Okay, let's just try to print anything at all. Print again, play, run again. Okay, so something is happening, but yeah, it's not being applied. So the problem is I added the group to the wrong node. It should be on the root, it should be on the head. So add player in here, but remember, remove it from here. Now save. Now let's exit. Now we detected the player. Perfect. That's exactly what we wanted. So let's just see now what we can do. So now let's go back to our 3D scene and let's think carefully. What is it that we need? We need some UI to know how many keys we picked up. Again, we did it the last time. First, you would create a canvas layer. Second, you would create some label, and then you would say, instead of pickups, just say keys, like picked up keys or something like that. Now we can just go to the display text, the label settings, new label settings, font 20. Now 20 is small. Let's go 30, 45 is nice. So keys, label, And again, 1, 2, 3. And let's do something fun as well. Let's say, actually, no, let's just not do it like that. Let's just do it like this. So let's just create this new, oh, we don't want to create a node. We want to create game controller script. That's what we want to call it. Of course, in the scripts directory, create, and let's also say keys value. Let's also save this one as a scene. So save branch as scene in scenes. Oh, it's called canvas layer. No, we want to call it game controller, and in here game controller, and of course inside let's just call it game controller as well. And let's remember, add a tag game controller. Now why did we add this tag? Because inside of the key we want to find the game controller and just say we found a key, and that's it. So how can we do that? If the player entered, then we want to find the game controller. So get3.get first node in group game controller var game controller. There we go. So now we have the game controller. Now we can say game controller dot pick key. That's it. So pick the key, like we picked some. Okay, good. Let's see now. If we actually come here, we don't have that function, so let's add it. Now, what is it that we want? We want to update the value. Now, let's see. And we want to know what is the current number of the keys that we currently have. Current keys count equal 0. So current keys count is gonna be equal current keys count plus 1. And let's see, what else do we need? We need to update the UI keys val dot text equal current keys count, but we will make it a string. And finally we will just put this as ready. Now you will see that I went really fast for this. Why is that? Oh, and we also need, like in ready, to assign the text to be actually 0. So you will see now I'm working really quickly through this. Like why? Like if you need more details, please watch the previous video that we did. Like we went through this like in slow motion, and we used the same exact thing but in 2D. So we picked up the key. But we can pick up the key multiple times, but we don't want that. We only want to pick it up once. So how can we do that? Again, the pickup, which is the key, should free itself. In other words, it should kill itself. Let's see. Okay, so it killed itself. Now, if we go back, where is the other key? Here is the other key, and we can't pick it up. Why is that? Because if we come here, now this is the key, but this is nothing more than a model. So delete, and again delete. Now let's go in here. Let's see, here is our first key, second key, and here is our third key. So now we have our third key. Okay, good. Now what else do we need? Let's say we want to display it like this. Maybe 1 of 3. You want to display like how many, you want to display the keys count like this. How can we do that? Let's do it really quickly then. So in here we can say var total keys count is also equal to 0. Now what is it that we need to do? We want to find out how many keys are in the entire level. To do that, let's use the tags again, or groups they are called. So on the key, let's go to node groups, and let's see, what are we going to call this? It's just a key. So let's just save and close. Let's go back to the game controller. In this script, we can say get3.get nodes in group of key. So now we will find like here's the level. This one will run here. It will search through this entire tree for all nodes or scenes that have the group that is named key, and we updated the key to have a group of the same name. Yeah, so it will just work. We will find them. So we don't want to find them. We want to find their size, their count. So that's what we essentially want. So we can do this, and now we can do this, but we're gonna do something really fishy. So let's just see. So I'm going to put this mark like this. Then I'm going to print like this, total keys count. Now let's just start the game. There we go, 0 out of 3, perfect. But in here, we don't want it like this. Let's see. Let's just pick up one key. Oh, it went to 1. We want to fix that. So how can we do that? Very quickly. Again, so this is called string concatenation. Basically, you add, when you use the plus sign to add strings which are text, the text will simply get closer to each other, like it will get merged with each other and become one text, and that's it. But for numbers, this is a number. Current keys count, this is a number. So yeah, when we add numbers, well, we all know how to add numbers. So yeah, so let's see now. So this is us turning the current keys count into a text. Let's add one more text. Okay, we added one more text. And let's add another text. So what is it what is the final text? This is the final text, which is the keys count. So yes, we turn the keys count into a text. Now if we start, boom, and we have it working very nicely now. We have 2 keys. Now when we have the 3 keys, we want this to update. Like, we don't want a UN screen. We want like a sort of quest system where it will tell us send the keys, like deliver the keys to the portal. Deliver the keys to the portal. That's what we want. So let's do that really quickly. Okay, so we picked up the key. Current keys count is greater or equal than total keys count. Then print, we want to deliver the keys now. So let's see. It's sort of like, it's not a questing system, obviously. Like, this is not a questing system for sure, but it's a good start. Like, when we are building, it's a good start for now. For us to build this level with the goal, of just delivering the keys to the portal. So here we go. We have this key, this key, this key, and as you can see, it didn't update, but we did print. We want to deliver the keys now. Now it's very simple. So here is what we're going to do. Let's see. First, we will just create a sort of control group to just fill, to just contain these things. So keys, container. Now if we drag and drop these two, if we start the game, we will get an error. Why is that? So whenever you move scenes across the tree like this, you always need to update the reference. So you come here, you click control, you drop it. Now we get the proper keys val. Now it's not going to throw an error. See, it works. Okay, so let's now create a new container and call it, let's see, deliver keys container. Okay, let's see. Now, what is it that we want? Just some label that says inspector, deliver the keys to the portal. That's it. That's all we need. Okay, so what is it that we want to have? We want to grab this, and we also want, let's see. So when we get here, we want to deliver keys container dot visible to be true. Again, if you don't know what visible is, we used it the last time. So let's make it start disabled. It's not visible at the very start of the game. Let's just start the game. It's not visible. If we pick all 3, it's now visible, but it's very small text. So let's just fix the text a little bit. So if we go back to 2D, let's go settings, font. No, we don't care about that. 40, definitely not 400. Let's go with 45. Let's just make the container actually fit it. Start the game, and it starts enabled, but yeah, we want it to start disabled. So we start disabled, pick up all 3 keys, now deliver to the portal, but we want to disable the keys container. Keys container, there it is. So keys container dot visible equal false. Again, this is just an application for the thing that we made the last time. Now, if I come here, I should basically, we should deliver the 3 keys. So, how are we going to deliver the 3 keys? Let's think a little bit. Well, the easiest and simplest and quickest way would be to go into the level, go into 3D, and come here, go here, again, area 3D, and let's just create one more box, and this is going to be a sort of hidden, like, it's not going to be visible to the player or anything. So once the players get close to this, like, let's say like this, portal, here is the portal. Okay, good. So let's just add a script to it. It's called portal, but the script should be, again, the scripts directory, create, and the portal should be saved to the scenes directory. So it's called portal again, and perfect. So let's enter the scene of the portal. Again, we enter the node, we click on the area, we go to the signals, and let's think. When the player touches this portal, let's say we want to print a message. We can think about whatever we want to do later. For now, let's just print a message. So, body entered. When the body enters, connect. There we go. Again, let's just use if body.is in group player. If it's the player group, then print like player is in portal. Like the player is in the portal. That's it. That's all we need for now. So let's see. Let's pick all 3. Let's move. Let's run, and let's see. So player is in the portal. Good. And we need to deliver the keys now. Okay, fine. Let's see. How can we deliver the keys? Where do the keys live? They live in the game controller. So let's get the game controller. Get3.get first node in group, game controller, var game controller, and there we go. Game controller dot, let's say, what is it that we want to say? It's not pick key. No, we want to make a new function and call it deliver keys. Let's see, we want to say deliver the keys. Okay, so let's see. So the portal basically delivers the keys. Let's go to the game controller. Let's create the function func deliver keys. And that's it. We should be now delivering the keys. So we know the player is in the portal. Now we just say deliver keys. So how can we deliver the keys? Well, it's like a unique way. So let's see. So how do we deliver the keys? Like, let's see. When we deliver the keys, we want this one to be disabled again. And we want to show a new. Let's create a panel. Let's put it here. UN panel. And again, label. Let's see. UN. So let's go to 2D. Let's just grab this panel. So I did, like, see what I did? So I clicked the panel, then I clicked this, and it expanded throughout the entire screen. Now I click the label, I click on the center, it moved to the center of the screen. And now let's go to font settings, new settings, font 50, 80. Yeah, that's fine. And that's good. And let's see. So when the game, like when we deliver the keys, we want to say UN panel dot visible equal true, and deliver keys container dot visible equal false. And of course we want to start this one with the game disabled, like we want to start this as disabled, Let's run. Okay, you win. We won. But let's see something really funny now. Let's just ignore the keys. Let's just go to the portal right away. Oh, yeah, that's not something we want. Let's see. What is it that we want? We want when the player enters. Like we want the following. So if the player enters, but we don't have all keys, we want to show a warning message and hide it after 3 seconds. Very simple. Very easy. So first, let's just do the proper conditionals. If current keys count is greater or equal than total keys count, then we do the winning condition thing. But what if it's not? What do we do? So we write else. This is the first time we use the else. So yeah, the else. So we want to show a hint, like a hint for the player that you should pick up the keys first and then hide it after 3 seconds. So let's create the hint. 2D again, create one more label. Let's just click this, put it in the center. Now it's the center. You should pick up the keys first. Actually, let's just create a small panel for it. That's better, I think. Yeah, let's just create a panel for it. Let's make it, click this, make it like this. Now it's expanded throughout the entire screen. Keys hint. There we go. Let's put this one again in the center. Let's just, let's actually make it smaller. Let's put the handles, and if you click like this, it will just be smaller. But if you hold Alt, it will become like, it will shrink in all directions. So yeah, it's now shrinking in all directions. That's good. We want it to be at the very top. So I just did Control Z so that it's like, I just did Control Z. So now I can just move it like this. Okay, good. So it's sort of almost at the center. It is sort of almost at the center of the screen now. Okay, good. So yeah, we should increase the font. Okay, so let's see. 35 is nice. Let's just click enter. So it's on 2 lines and it looks ugly. So let's put it through centered like alignment. And here is the pickups hint. And let's see. So let's just drag it, drop it here. Pickups hint dot visible equal true. Okay, so what else do we need? We want to hide it, like we want, so it will start hidden. Let's see, it's gonna start hidden now. Let's go. Okay, you should pick up the keys first. That's how easy it is to make games in Godot. So you can see we are essentially building our game logic. Of course, you could do that essentially like in any other engine, but yeah, like so it's fine. It's fine. Like Godot is very nice, and like we're progressing quite nicely so far. So. And all of this is just an application of what we did the last time. If you are finding this overwhelming, please watch the previous video. We made something very similar to this, but like a bit easier. So pick keys hint. It shows up, but it never vanishes. How can we make it vanish? We need a timer. So timer, keys hint, timer. Let's come here again, drag, drop, left control, and there it is again. So we do this timer. Let's see. Nothing. We will just start the timer. That's it. So the timer, how long it will take before it vanishes? Let's say 2 seconds, 2.5 seconds maybe. That's it. And what else do we need to do? Let's just think for a little bit. It will be a one shot, so it's not going to loop. And it won't auto start, so it will not start at the very start of the game. And let's remember, we need to connect it with the code so it actually makes the hint vanishes. So we go to node, we go to signals, we pick the timeout. Now this function will get called the moment this timer runs out. So that's very simple. Now all we need to do is pick keys hint dot visible equal false. That's all we need. So let's just start the game and see what we need to do. So pick the keys. You should pick up the keys first. It's gone. Good. I picked up the keys and you win. I won. We won. Yay. Okay, good. Okay, so now we have one more thing we need to do. We need to restart the game after we win. How can we do that? Again, very simple. Let's remember the very last time in the last video how we restarted the level. We used a timer. We restarted the level after 3 seconds or so. And of course, we just used a timer. So even if you didn't watch the last video, we should be able to do it. So let's do it really quickly. So timer, let's see, UN timer. Again, we need to get this and put it like this. Now we have the UN timer, and let's see, where do we show that we won? When we deliver the keys, UN panel is equal to true, and UN timer dot start. We just need to start the timer, and finally we need to put the time that we need to wait. We need to make sure it's one shot, so it only plays once, and it doesn't loop, and it doesn't auto start at the very start of the game, so it should be false. And finally, node signals timeout, which will be called basically when this timer runs out, it will call a function on some script. We don't know which function, we don't know which script, so we connect it through the editor. Double click, choose the game controller, click connect, and now let's just see, we can now restart the level. So get tree dot, let's write the word scene, and we have reload current scene. Perfect. So start the game. We have our game logic. We picked up the 3 keys and we won. We keep doing whatever, and then in 3 seconds, as you can see, you win, and in 3 seconds the game restarts. Now we want to go through the extra mile. We want that, we don't want the player to move after we have won. We want the player to freeze. So yeah, that will be a very fun challenge. So let's actually do it really quickly. We want the player to stop moving. That's fair. So where do we need to go? We need to go inside of the player. Let's think. Where do we read the input? Where do we read the input? By the way, I explained this script, a very similar one to it, in the last video. So we could do that if needed. So yeah, watch the first video to realize how does the velocity work. This is sort of built-in behavior in Godot. You just add the script, it gives you this code, and you can move right away. Cool. So where do we read the input? In here. Input.getVector is how we read the input. We read the left, the right, the up, and the down, which are the 4 arrows. So basically, we just need to exit. We need to exit this function early. Once the game is over. Let's see. How can we exit a function early? That's the first thing we need to be careful about. How can we do that? You use the keyword that's called return. Okay, so let's return. Now we return early, we exit early. See, we can't move at all. Good. So now we know this line makes us exit early, but we don't want to keep exiting early all the time. We only want to do that once the game controller tells us the game is over. So that's what we need to be wary of. How can we know that the game is over? Again, very simple. We need to find the game controller, because the game controller knows whether the game is over or not. Tree.get first node in group game controller var game controller. Now we have the game controller stored in this variable. Cool. So what else do we need? Let's think a little bit. We need to know whether the game is over or not. It's simple. Let's see. Let's just print whether the game is over or not. Print game controller dot is game over. Is the game over? It's going to be a function. Let's do it like this. Let's just start, and we will get an error. Why is that? Because is game over does not exist. We didn't create the function. So let's come here. Let's see. Func is game over. Now we're creating whether the game is over or not. So when is the game over? The game is over in here when we deliver the keys. So let's create a new variable, var has delivered keys. It will start as false. Now let's come here. Has delivered keys equal true. So let's see now. Is the game over? So is the game over? Like it doesn't tell us anything. It just gives us a pass. Maybe we can make it print. Maybe we can make it print. Is game or has delivered keys. Now it just prints whether we delivered the keys or not. Let's just start. Okay, so it's giving us some weird values. First it's giving us a false, and now it's giving us a null. Let's just say we wanna remove this line and we wanna say a pass, and that's it. Let's run the game. It's going to stay nulls now. Now what's happening? Let's remember, we are printing in two places. Let's print. We're printing a false and we are printing a null as well. So let's go to player ship. Oh, so we are printing this function. Okay, but what if, is there, like, what? Let's think about it. So is there a way to make this function give us this value? It's actually there is. It's a standard programming thing. You return values from functions. So this function currently doesn't return, is game over, does not return anything. So it's printing null. But this value is filled. So how can we return this value, which is has delivered keys? We just use return has delivered keys, start the game. That's it. It now prints false. Yeah, it's now printing false. Good. Okay, so when do we exit early? We only exit early if the game is over. So if game controller dot is game over, and then these two, like 2 points on top of each other, and then let's look. Oh, there is an error, an indentation error. Why? Because like this is an if statement, and we need to tell the if statement what is inside of it. It doesn't know. How can it know? You give it an indentation. Now it knows that this line is like this return belongs to this line. Let's see. Now we can move. We picked up the keys. We delivered the keys, and you win. We won, and the game has restarted. Perfect. But there is one small problem. Let's see. How do we find the game controller? We find it in process. Now process runs every single frame, like in 1 second. Now this is physics process, so it will run based on the physics engine, which is like 30 times a second or 60. I think you can configure it. In any case, it doesn't matter much. What matters is that it runs so many times, and you should never find, see, like whenever you see, like you should never get nodes inside of process functions, because that's like a heavy operation. So you need to store the value. Let's see. Func ready pass. Now when does the ready function get called? By the way, this is the fixed update from Unity, and this is the start function from Unity. So this is the start function. So this one will only get called once, like when the game starts, but this one will get called every single frame, so many times. So what we need to do is to save the game controller. So let's just drag the game controller, put it here. And now we need to take this code and put it here and say game controller equals this. So previously, what we did was we were defining a new variable called game controller every single frame. Then we would look and search through the entire tree until we find the game controller. But now we don't do that every frame. No, we only do it once at the very start of the game. So at the very start of the game, we find the game controller, and then we are ready to go. We are good to go. Like that's it. So we just use the game controller directly, and that's much more performant. Now we should get the same behavior, but it should be better performance. One thing we want to see, so you saw me, I expanded the screen, and you might have noticed that my screen is somewhat bigger, like the game display. How can we fix that? You go to project settings, you go search for display window, and there you go. You can now change it. Let's do this. Let's close, save, run. The screen is bigger, and that's how you basically make the screen bigger. But I want this resolution, and there we go. So yeah, there we go. Now we have all of our goals. Let's go back to the level, go back to 3D. Let's put the 3 keys inside of their appropriate places, and let's put the player ship in its appropriate place as well, which is the origin, or the yeah, there it is at the very start of the level. Now we have the core game logic. Now we need some fun things like the enemies, the towers, and so on. Let's begin by going to the 3D world, level 00. Let's start by having this ship. Our goal is to have this ship and make it basically detect the player. First things first, let's take this ship, move it outside, and let's collapse the level elements. Let's take this, let's create a new empty, not a node, like a node 3D, and place all our keys and the portal inside of it, and we'll call it completed level element, something like that. You can give it a better name, whatever you want. So let's see. Oh, and also we have the corridor. Where is it now? Yeah, it's not really needed, so let's just remove this corridor thing. Okay, good. So our goal now is for this. We want to make this one into a unit. So first things first, we need to make it on 0, 0, 0. The scale can be like whatever, it's fine. Why? Because first, let's think. What is it that we want from this ship? We want it to move. So what do we need? A character body 3D. Now we will grab the model, place it inside. Now we will add the collision shape 3D. And let's think of some shape that actually fits this ship. Now, of course, do note, I will click on the root, call it enemy ship, and then I will move the root. Let's pick the moving tool, and I will move it. So now the root has been moved. Do keep in mind, if you move the model, things will go wrong. If you move the shape, also things will go wrong. What we need is to only move the root, and this should be at 0 position, 0 rotation. This should be at 0 position and 0 rotation and 1 on the scale. So let's see, what is it that we're going to add? Let's have a small, easier to deal with collision shape. Let's pick a cylinder, but the cylinder is in the wrong direction. So let's just move it, change its rotation. So let's just rotate it on the X by 90 degrees. Okay, now it's more sensible. Let's make it smaller like this. Let's just move it up a little bit. That's way too small, and that's it's way too long. So let's change the height to 1. Let's make it 0.225. Okay, I think 0.3 is good. So that's going to be the collision shape of our ship, or the enemy ship at the very least. Now we need to save it. So right click, save branch as scene, enemy ship, put it in the scenes directory, save it, go inside the scene. Let's just give it some tag first. Let's say this is an enemy tag. We may need it, we may not need it, I'm not sure, but yeah, for safety. Now let's see, what else do we need? Let's think a little bit. Oh, we actually need a script so that this ship can do things. And let's also reset it to 0 in here. So scene, save, click here. We want to create the ship. So scripts, open, save. Okay, so we have our ship, but it uses gravity. We don't care about gravity. Actually, we don't care about any of this. We don't need to move based on the keyboard input. So let's just leave it fully empty. Okay, good. So what's our goal? Let's first just go to the 3D world. Let's just make sure that the player can actually collide with the ship. So let's see. Okay, so we can collide with the enemy ship. That's Fine, that's great. Now, what else is there? Something that we need? Well, let's say we want to print a message when the ship, let's say we want to print a message when the ship detects the player. First, the player has the tag player, so that helps us. So how are we going to detect the enemy ship? How are we going to detect the player ship, I mean? Well, it's actually really simple. Let's say we want to detect the player ship based on a circle around the enemy. So if the player is inside of the said circle, let's just make a circle for visualization. So I'm going to create a node, call it mesh inst, and let's create the sphere, like a sphere. There should be a sphere. Okay, so we have this sphere. Let's say our sphere is going to be like 3, 3, 3, or maybe like a 4. So if the player is inside of this sphere, we want to alarm the enemy to chase the player. Let's make it like a little bit transparent, because if we can't see anything. So let's just make it a bit transparent. That's actually going to be really simple. So you go to surface override material override, click here, click plus on the new standard, then come here, go to transparency, make sure to make it alpha or something just so that it's not disabled. Then go to the albedo and just do this. Okay, so let's just say give it maybe the color green. No, that's like a bad color. Let's make it more like this. Okay, so we have like our sphere that the enemy uses to detect the player. What we want is when the player is inside of this circle, we want print a message. That's all. So how are we going to do this? Let's just think a little bit. Now that's going to be a bit difficult. Actually, not really. We use something very similar to it. You remember how we pick up these? Well, instead of picking it up, we will only create like an AI detector that detects the player. So I will right click in here, click cut, then go inside of the scene and then click paste. Now there we go. So we have now, if you go back, let's see, like that sphere doesn't show up on any of the enemies. But if we save this, now all enemies should have the sphere. But why don't these enemies actually have the sphere? Oh, that's an error. Actually, it's not, simply because we did not replace them. This is just the model. We did not replace these. So I'm going to remove this. Let's create more enemy ships, and I'll move this one there. And finally, I think I moved it to the wrong place. So let's see. I'm going to click like this, and let's put it here. And I'm going to click Ctrl D again and click on this green square and just move it here as well. Okay, so now anything we do, let's just create a new empty scene like for organization and make sure it's on 0, 0, 0, and just put all our enemies inside of it. It's always best to be organized. Let's collapse this one. Okay, good. Now we can also just drag this and put it here, and there we go. So we have all of our elements. And let's also drag the environment collisions inside of the environment, because it's a part of the environment. Now you know how we handled it for this level. But of course, for the future levels that you create, you shouldn't use this trick. You should create a new scene, include the collisions inside of it, and place that scene instead. Okay, good. Now that we are inside of the enemy scene, we want to create that detector that is inside of this sphere. Because now, even if we enter it, nothing will happen. So we go click plus, create area 3D, click plus, double click on it, and it will get added. Now do note, we are inside of the enemy ship, and we created another area 3D inside of the enemy ship. So we create a new collision shape 3D. Let's just create a sphere shape. Now if we click and expand, now let's just look, it's roughly the same, almost the same. Let's just observe the shape. So 2.5, now it's exactly the same size. Let's look at the transform in here. So it's 5. So like obviously 5 is the diameter, but 2.5 is the radius. So 2.5 is the radius. So now let's just drag this. Let's just put it here. It doesn't matter where you put this mesh instance, but this is like a part of the detector. So let's keep it inside of the detector. Okay, good. So what do we need now? What are we going to call this? Let's call it ships detector. Ships detector. Okay, that's a good name. Detector visuals, like the visuals of the ship detector. Yeah, I think ship detector is better than ships, so I'm going to remove the S. Now I'm going to just click the plus icon and save this one inside of the scripts directory, and we're going to call it ship detector, and that's a good name. Let's create the plus icon. Okay, so we saved we removed the initial script. Now let's think, how are we going to detect the when the player has entered? Let's see. So we will go to the node, click on the ship detector, click on the body entered, because it's a body that we are searching for. Now look, we have two places where we can actually find whether we detected a ship or not. If we click where we shoot the signal, let's just put it here, and I'm going to go back, double click again, and now I'm going to click here. Now look, we have on the ship detector a message, and we have on the enemy ship another message. Like you can see the difference in here. This one is from here and this one is from here. Okay, good. So let's just print a message from here. We found a ship, and we're going to print its name. Now where are we? We are in enemy ship. This is the enemy ship script. Now if we come here and print a message, like we found a ship, but it's not like an enemy ship. It's and we have not an error. I clicked on here by mistake. You can see we can put some breakpoints which are used for debugging in here, and that's why the game paused. There was no error, so I'm going to remove it. Like you can click once to add it, click again to remove it. Now I click play, and there we go. So let's see and observe. First things first, we have a lot of messages. We have so many messages. Let's just move closer, and it says it found the player ship A, and it says we are in the enemy ship, and we got it in the right place twice. So first we found it in the enemy ship script, and then we found it in the ship detector script. Okay, good. So what do we actually need? We don't let's see. So we're going inside of the ship detector. Let's click here. Now it's printing everything, and we don't want that. Let's print if body dot is in group player, then we print. Otherwise there is really no need to do anything, and let's just remove this function because we don't need it at this point. Okay, let's just save. Let's just see. Now if we click again, let's see, we have a bunch of errors in here. Error signal body entered callable, but you can read the entire error, and but it says the method is not found. Why is that? Well, we removed the function, but we did not remove the connection from here. So we also need to remove the connection. So let's see. We're going to remove this connection because we deleted the script where it was. Now, if we start the game, we get no errors. And if we enter, as you can see, we get this. So player ship detected, and we are in the ship detector. Perfect. So now we know that the player is inside of this sphere. The player is inside of this detector. But let's look at our ship. Now our ship has this as the front. So you can see the ship is facing this direction. Now let's think a little bit. Do we really want the ship to detect the player in a circle? Maybe that's what you want for your game, but for me, I want to go a little bit beyond that. For example, if let's just create another mesh instance. Let's just give it the cube or box. Now let's say this is the player. If the player is in the back, I don't want the enemy to detect him. I don't want the enemy to detect him. If the player is in the back, I don't want the enemy to detect him. Maybe you want that for your game, that's fine, but let's explore how we can do that, where we basically reject all entries where the player is behind this ship. Okay, now that might be a little bit difficult, but let's see what we can do. Let's just create two boxes actually. Yeah, let's just create two boxes. So create box mesh and then new and another box mesh again. Okay, so let's see, what am I now going to do? I'm going to just create another empty. Okay, so I'm going to create a marker node. And I'm just going to drag it outside, and I'll take this one. Now, do you remember the displacer trick that we used previously? We're going to use it again. So let's see how we will do that. I'm going to drag the actual, by the way, what is a marker? A marker is just this. This is the marker basically. It's just an empty node 3D that basically has a small gizmo like this. There it is. Yeah, that's how it is. That's all there is to it. It's the same as a standard node 3D, but it's easier to see in this scene. That's all. So I'm going to drag this and put it inside of it, and let's just put it like this. Okay. Now what am I going to do? I'm going to take let's call this one first arm. Now our goal is to have the enemy detect the player in an angle like this and like this, in a cone, like basically in a cone, like from here to here, or maybe from here to here, and so on. So how are we going to do that? Well, we're going to do that through the following. First, we will create the arms. So how are we going to do that? I created this, and I will just take the transform and just move it like forward by 0.5, which is half of this scale. Now, if you can see, our block or our cube now has the pivot at the very back, I'm going to take this, which is the marker model. I'm going to click on this. Now the link is broken, and I will put it on the Y to be very small and on the X to be very small. Now it looks like a small arm. There you go. You can see it's a small cube. Let's just put it back to where it was, which is like at the very center. Now let's think. Where do we first we wanted to touch this, like let's just see how can we make it touch this. Well, very simple. We do this, like unclip this, remove the clip. Actually, we are not going to change the scale. Let's just create another empty node and just put it like this and call it scale displacer. And now we can come here and just scale it, like remove the clip. Now we can scale it on the Z. Now look, now it's like that. Perfect. 2.5. Good. Now we have the first arm and the scale. Let's just put the angle, I don't know, maybe 45. And let's create a second arm. And we, like we duplicated it. And let's just put it at minus 45. Okay, perfect. Now if there was no need for the secondary cube. Like we have two arms, that's all we need. Now let's just start the game. You can see we have this. Let's just move it a little bit above, and okay, so we detect from here. That's not fine, but we would detect from here as well. Yeah, well, we only created the arms, but we didn't really create anything about the actual detection, so that we only detect while we are inside of the arm. So let's think how are we going to determine whether we are inside of the arm or not? Okay, so how are we going to handle this problem of basically finding the how are we going to handle this problem of basically finding the angle, like the first, or like finding whether the player is inside of the cone or not? So there are multiple ways, and you can see I modified the script a little bit. So now we have the first arm, we have the second arm, and we also have the is like body is in group of like is the player. So yeah, now you can see, you know, basically we print is the player inside or not. So let's see, player is inside the sphere, but is he inside of the cone? We don't know. So let's print whether he is inside of the cone or not. So the way you might think about it, like you would click here, I mean inside of this shape, then you would come here. The idea that might come to your mind is that you have the angle in here and you have the angle in here. So if the player is within the angle of -45 to 45, then like the player is inside of the cone, and that's correct. Well, the problem is, how are we going to get this, like the angle between the player and the enemy ship? Now we like that might be a little bit difficult. So let's see what we have. So I have this code that I prepared like earlier. So let me just put it here. Let's just see. So we have two functions. Like this function we will delete it later. And basically what it does is that it will print every single frame the angle between the enemy ship and the player. Do note I disabled the other enemy ships, so we don't get mixed results basically. So in here I clicked on this ship, I went to process disabled, clicked in this ship, process disabled again. Let's hit play and see what we have. So let's just see. So we have this angle like this, it's almost 0. That makes sense. Let's move back, like, yeah, you can see it's almost 0, so that's fine. If we move to the left, like you can see it's 35, that's fine. But then it starts going smaller. What? And then in here, it's almost 0 again, but 0 from the other direction. Okay, now that's a bit weird. So you can see the values are not what we expect. Now, why does this happen? Because 3D rotations are just hard. And like in the 3D world, you should always like avoid using angles and degrees like as much as possible. There are more complex like notations or like more complex notations that you can use for rotation, such as the quaternion or the basis that Godot provides. And for rotating things, you should probably always use these, but these are a little bit more complicated to use if we're being fair. And so let's see how are we going to deal with it. We're going to deal with this problem through the dot product. So let's go back to 3D. Let's go back to the enemy ship. The arm has this blue arrow. See, there is this blue arrow. The second arm, or like the first arm, has this blue arrow as well. And the ship root also has this blue arrow. Okay, has this blue arrow. Let's see these blue arrows. What if we apply a dot product between this blue arrow and this blue arrow? What number are we going to get? Actually, so the dot product is sort of like multiplication between two vectors. And yeah, the result of this multiplication is a number that does not change. Okay, is a number that does not change. Let's see what I mean. So first we're going to get the my blue arrow. How can we get that? It's very simple. So global transform dot basis dot z. That's the blue arrow of the enemy or like of the detector. Now var first arm blue arrow equal global transform dot basis dot z, but not our global transform, the global transform of the first arm. And obviously in here we just say second, and in here we say the second arm. Okay, perfect. Now we said we wanted to apply multiplication. Let's see how can we do it. So var let's store it. So let's say the minimum dot. Let's call it like that. So how can we multiply the two vectors? Like the first, these are not numbers. The arrow is a vector. Okay, so when we say vectors, we basically mean an arrow, not a point, or not a number. So we say like this multiplied by this. Now this will give us an error. Oh, it's actually working. I'm very surprised. I honestly don't really know what will the result be. So let's print it and see. I think there will be an error. There should be an error. Let's see. Okay, so there are no errors. And let me just comment out this code that I had, which prints this like every time. Oh, interesting. Okay, so I guess the operation is somehow, some way defined, and that's fine. I guess, yeah. That's not the multiplication that we want. That's not the multiplication that we want. Is called a dot product. So you say a point like this and then dot. This is what we want. This is a mathematical operation, basically. It's just a mathematical operation. Some math, basically. So we do some math between these, which is like a multiplication product. Now, let's see the number. See. The number is 0.75. It doesn't change wherever we are coming from. It doesn't change regardless of the place we're coming from. Okay, what about let's say this will be the max dot, which will be the dot product between the second arm and the same blue arrow that we have. Well, will be very funny. It will be the same result. Let's see. Let's just see it in action. So it's going to be so let's see. Oh yeah, I didn't global transform dot basis dot z. That's what. Actually, no, we already got the value. So let's just put it here. I put the wrong variable there. So let's see. Okay, so it's the same number. Why is that? Because the angle is minus 45 to 45. Minus 45 to 45. So that's the problem. This is or not a problem. Like that's the key. So this value doesn't change regardless of where we are. Okay. Now how can we get the dot product then between our player and let's get the dot product between our player and the enemy ship. Well, first we need a blue arrow between them. So let's just draw an arrow. Let's imagine there is an arrow like this, okay? Let's imagine there is an arrow like this. How can we grab it mathematically? It's subtraction, okay? When you subtract, you create an arrow. So var, let's say, not player, like let's say body dot global transform dot origin, which is the position of the, displacement. So yeah, that's we need to store the variable somewhere. So we are storing it in some place called displacement. So this will be the displacement between these two. First, let's get the displacement. So which is this line. Essentially, it's this line, like the minimum line that you can draw between two objects. That's what we are getting, which is the arrow basically between them. So now let's say global transform dot origin. Origin is like our position. So let's print the displacement. Okay, let's look at the values. It makes sense. It actually makes sense. Let's just move this one a little bit up. Let's move this. Okay, so it makes sense. So look, so basically it says the displacement, this ship, which is our ship, needs to move this amount to the left and this amount to like forward and backwards, so it becomes on top of this ship. So it's like an arrow at full length. It's an arrow, like a long arrow from here to here basically. Okay, good. Now we don't want the arrow. We don't want the long arrow. We want a short arrow that has like a value of 1. That's what we want. How can we get that? It's called the direction. So direction to player equal displacement dot normalized. Now if we print this, like, it will make more sense now. Look now, what does this now? Normalization is another mathematical operation. It basically does the following. Previously we had values of like 0 point, like 2.5 or something. Now it's between 0 and 1. So let's just click this. Now let's see. Look, it's almost 1. Now if we come here, it will, now it's almost 1 in here and almost 0 in here. Now let's make it like this. Okay, so it's almost 0 in here and almost 1 in here. So the value never goes more than 1, okay? And when we are like at an angle, it will be like this. Okay, perfect. So now what if we apply the dot product between my blue arrow and this one? My blue arrow and this one. So that's going to be interesting. Let's see the result. So to direction to player dot and my blue arrow, and let's say var dot to player, like the dot product to the player. Let's print this dot product to the player. Let's see. Now you can see. So when we are like at a 90-degree angle, it's almost 0. If we are in this angle, it's like 0.7. Okay. If we are in here, it's 1. If we are in the back, it's negative like 0.9. In here, negative 0.5. And in here, let's just see. Let's see this angle. Let's see this side. So it's 0.9. Okay. Let's just grab it like this. Move the enemy like someplace here. Let's just start the game again. This might make it easier for us to see. So back, it's negative. Okay. And like this, it's 0.7 something, and like this, it's 0.7 something, and like this, it's 1. So how can we know whether we are in this angle or not? Basically, if we are between 0.7 and 1, if we are between 0.7 and 1, then we are inside. So we can say if dot to player greater or equal than 0.7, then print we are inside the cone. We are inside of the cone. Let's see it now. Okay, so see, we are inside of the cone. Let's see now. We are not inside of the cone, so we do not print anything. Okay, well, instead of writing like 0.7, why don't we just use like one of these two dot products? Like, why don't we use like one of these two dot products? Like, they are equal, so we can use any one of these. So let's just make it like this, and we can remove the other dot because we don't need it. We don't need the other blue arrow, and there we go. So now we have a cone of sight, basically, or like a sort of not line of sight, but more like a cone. So if we are inside of this cone, then like we don't know if we are inside it. Now we are inside it. We are inside the cone. Okay, good. So that's how you basically detect whether you are inside of the cone or not. Let's call this one like testing dot. The testing dot product, basically, because we test the dot to player value with this testing dot. Okay, what if you want now to change the angle? Now you can just say negative 90 to 90. Let's just hit play. We are inside of the cone. We are not inside of the cone. See, it will continue to work. It will continue to work. Now, do keep in mind, if you make one of the arms at this angle and like one of the arms at another angle, then that might cause you problems. That might cause you problems, and it will not work as you expect. Why? Because if we remove this one, you will realize that we only test, like we only use the first arm dot product for comparison. We only use the first arm dot product for comparison. So the angle between both arms should always be equal. The angle between both arms should always be equal. But how can we rotate them? That's a hard question. We will do it when we make these towers. When we make these towers, we will see how we will rotate them. For now, we don't need to rotate them. Let's just keep it as it is. So we have this ships detector or ship detector, and yeah, that's all it does. It just checks it. Oh, let's just also fix the angle. So minus 45, and this one should be 45. Okay, good. Now if we run the game again, now we know whether we are inside of the cone or not. So that's just perfect. Now I know this part was tough and it was quite mathematical, and there is like an alternative way using ray casts, and that will be more like line of sight rather than cone detection. But that's like something for a future video. For this video, we will not use ray casts, and we will just abuse this mathematical thing, which is the dot product and the normalization. They're very performant, and yeah, so you don't need to care about them much. If they serve your purpose, then yeah, you don't need to do anything else other than that. Okay, now one magical thing I'm going to do, I'm going to store this ship detector as a scene. Can we do that? Yes, we can. So save branch as scene, ship detector, save. Let's save this. Now, as you can see, this is now a separate scene. If we open it, this in the 3D view, now we have it like this. Okay, good. Now, if we go back to the level, let's move the enemy a little bit to the side. Let's grab one of these towers. And our next step is making these towers actually detect the player as well. So let's grab the model and put it here, and there we go. Now let's create really quickly the detection for this tower. Let's just create a new node 3D. It's on 000. Let's put the like tower model inside of it. Let's reset this one to also 000. Let's grab the root. Let's call this one guard tower. Let's move it back. Okay, good. Now, how can we add detection really quickly? Do we need to create the area 3D and then add the tower and then add like the visuals and then add the scripts? No, you don't need to do any of that. Why? Because we made our, let's go back here. We have ship detector. Just drag it, drop it. There you go. Your ship detector is now in place. Your ship detector is now in place. So let's see, what else do we need to have? It's probably useful to create a script for the guard tower. So guard tower, let's put it in the scripts directory. Now we can just right click, save branch as scene, and we can save the guard tower. But now the question is, can the guard tower actually detect the player? Let's just test it. Let's just test it out. So if we move forward, oh, it's actually already working. So we are inside of the cone. There you go. As you can see, we are inside of this cone. Perfect. So it's already working. Let's try to rotate the guard tower like backwards. So let's put it like this. Let's hit play again. Now, what does it say? It says we're in the sphere, but we are not looking at the correct direction. So let's just rotate it. Go back in here. Now if you go out and go back inside, we are inside of the cone. So there you go. Now you have this one working again, but our tower is facing a very weird direction. So let's just reset it to 0, and let's make sure the head of the tower is actually in the right direction. So I'm going to click the rotate tool. I will click on this one. I will just rotate it, like click on the green circle, rotate it like this. Let's see. So like, what is this? Like, let's see, 60 angle and 0, 180, and this one can be 180, and there we go. So that's our tower. Let's just, I don't know, light, spotlight. Let's put it inside. Let's just see what we can do. So transform, let's just reset everything basically. Okay, so our light is looking very far like into space, and that's not something we want. So let's just put our light something like this. Okay, so that's working, and the angle is very large. Let's make the angle like 30. Perfect. Now we have a warning. Let's see. A light scale does not affect the visual size of the light. Yeah, that's fine. Like, that's all it says. Like, the scale was weird, so yeah, it tells us that the scale doesn't affect the light size. What affects the light size is the angle and these two variables. This thing, like, yeah. So in any case, okay, let's put this one back to 1. Let's the angle, put it maybe 25. Range, angle attenuation, okay, doesn't matter. Let's just start the game and look and observe our beautiful tower. Okay, so our beautiful tower doesn't show any lights, probably because it's outside. So let's just do this. Okay, so something is different, but the light is very weak. How can we make the light stronger? Let's think a little bit. Let's just click light, energy, give it 5, hit play. Yeah, there you go. We have our strong, powerful light. Okay, now let's think a little bit. How can we rotate the angle? We don't want it to like work continuously. We want to rotate the angle, and that's the easiest way. That's the easiest way where you can rotate. I mean, not rotate the angle, like I mean, rotate this tower. So yeah, that's how you do it. You would just do this, and there you go, it rotates. So how can we rotate it through gameplay? Well, we will create an animation player, which is the first time we actually use it. And then let's just create a new animation, call it idle. So this is the view that we have, that where we can create our animation. So let's see. If you want to rotate like the entire detection angle, you can do that, but I'm not going to do that. I'm just going to rotate this small barrel and nothing else. So first things first, let's see. This one will be autoplay. This one will be loop. That means it will play like continuously. And now let's begin by clicking this key icon, create. And then let's see. So the animation length is 1 second. Let's like at 0.5. Let's make sure the barrel is like rotated to this side. Like let's say 120. Let's just hit the key. And in here it's going to be rotated like in the other direction. So minus 120. Let's hit the key again, and finally, oh, we can't like progress more. So let's just make the length 1.5, and the length of 1.5, it should be like this, which is the return to the original value. Let's see the tower. Okay, perfect. As you can see, the tower is animating perfectly. Now, of course, that's a very poor animation, so we're going to fix that in a moment then. So what we are going to do is we will start from 180, and now we will press the key, and then I'm going to remove all of the old bad keys that we had, and now we can say 120, which will point through this, and then click this, and then we will go again to where we were, which is like 180. But yeah, let's go back to 180, and then at the very end we will go to 180 plus 60, which is 240. And finally at the very end, let's add like some more time, like make it the length 2 seconds. And now the animation should work fine. There we go. We have a proper guard tower. But again, what if we want the detector to actually rotate properly with this? What if we want the detector to actually rotate properly with this? Again, very simple. You come like this. You open the transform. You click this. You click create. You click 60. And then you go back in here. Click 60. Oh, actually, it's, let's see, so minus 60 maybe. Let's see. Yes, so it's minus 60. Click here. And then in here, we are back to where we should have been, which is here. And now we have positive 60. And finally, we have the original value. So let's just save. Now let's look. There you go. So now the detection cone is actually working properly. But the animation is very quick. So let's just make it 4 seconds and make the snapping to be 0.5 rather than 0.1. This will make it easier for me to move the animation keys, as you can see. So that's 0, 1, 2, 3, and that's on 2, and this is on 1. Okay, so it's much slower, but it's nicer. I think this is nicer than before. So now let's just save, hit play. There you go. So you can see our tower is scanning properly. Now for the tower, I think it would make more sense to just I don't know, hide the legs maybe. Yeah, I think it might be better to just hide the legs. How can we do that? You go back to the guard tower, right click, editable children, and let's just hide this and hide this. There you go. What if you want, like some arms? Like what if you want some arms? You would just recreate these arms. Like you would just only need to recreate these arms like manually, basically. You can like copy, paste, and let's see. So let's put it in here. Oh, you can show it, and there you go. So now you have your arms. Maybe minus 45. Let's see again. 45. Save. Now the arms don't move, but the actual logic moves, and it's your call. Like basically, it's just a visual style. For me, I'm actually going to be somewhat creative and do this. One more duplication, 0. One more duplication, and 180. And there we go. We just finished our tower. So we have towers right now. Now we just want to add a very small update for our ship detector, such that we have a new small toggle that we will have in here, and when we toggle it, it will basically stop using these arms altogether and just rely on the sphere alone. So how can we do that? Well, it's really simple. So we come here, we click here to open like the script. And now we are going to come here, add some spaces, click the add sign, write export, then var, and say can use arms equal true. Let's just save scene. Let's just click again. Now we can see it has can use arms. Okay, so what we want is as follows. If we can use the arms, then we are going to do this test. If we can't do this arm, then we are not going to do the test, and we will only compare like the body entered, and that's it. So let's create a new function. We're going to delete this function, and we're going to create a new function. So we're gonna call it func process entered body, and it's going to have a body. Again, we are going to do as follows. Let's just take everything in here and just place it here inside. Now if we run our game, nothing will happen. Let's just start our game. Yeah, obviously nothing will happen. So we're going, because we didn't call this function. This is a new function we created ourselves, but we're not calling it. So let's call it. Let's call this one, and now we need to give it the body. Hit play, enter. Okay, so we are inside of the cone. Now let's just come here. And let's come here, and okay, so this one is not working. What? There is something wrong. Okay, so this one is working. That's nice. Sort of working. Oh, and yeah, there we go. So something is weird going on, but that's fine. Let's just ignore it for now. So let's now take a look at what we have. So the function is getting called. So instead of printing this, we want to return a true or false. We want to return a true or false. Did we process this body successfully or not? Okay, that's all we need. So if the body is player, and we are inside of the arms, then actually wait, no, we need to use this thing first, which is like can use arms or not. So let's see if we can use arms, then we are going to print everything. So I'm going to select all of this code and add a tab. So all of this code now belongs to this if statement. But what if we can't use the arm? What are we going to do? Let's just go back one more step, click else. Now we added the else, and we will print we cannot use arms. No need to do the arms test. That's what we want. So now we can't use the arms. Let's just save, let's just enter so you can see. Let's actually just keep it simple, and I'm going to move the tower away a little bit. Let's just move it there. And now I'm going to take this enemy ship, which is enabled, and I'm going to just put it here, and I'm going to run the game. Let's run. Okay, let's enter. So let's see. Player is inside of the sphere. Is it inside of the cone? We are inside of the cone. That's great. Let's go inside of our enemy ship. Let's come here, and we're going to remove this one. We're going to assign it to false. So let's set it to false. Let's just start the game now. Okay, let's look. Okay, so what is it that we have? We cannot use we can't use arms, so no need to do the arms test. Perfect. That's good. Let's go to the ship detector. And what are we going to do? We are going to return a true or false, whether we successfully detected this body or not. So let's see. If the body is like if the body is in the group of player, then we need to make sure whether we can use the arms or not. Like if we can't use the arms and this is a player, then we simply return true. Like the return is always the last line basically. So we return true. And if we can use the arms, then we need to obey the arms test. So if we can use the arms, if we are inside of the cone, then return true. What if we are not? Then we're going to add the else and then these two dots on top of each other. And now we want to return false. Okay, let's look at what we have. We have if the body is in the group of player, then we check whether we use the arms. If we use the arms and we are inside of the arms, then we return true. If we are not inside of the arms, we return false. What if we don't use the arms at all? We return true directly. But what if we are not inside of this group, which is the player group? What are we going to do? For now, we don't return anything, so we need to return something. U backspace one more time. Look at the indentation. Oh, I misclicked. Let me expand the function again. Okay, good. So let's look. Here, this if statement has one indentation, and in here we have one indentation. So this one is on the same level as this one. So this else is the same as this if. Like this else belongs to this if. And so let's think. What are we going to do if we are not in the group of player? What are we going to do? Well, we return false. Now we don't need to print messages. Let's just print let's just remove all the prints, and let's say we want to print the result of this function. It's going to be either true or false. Let's see. So for true again. Why is it true? Because like yeah, we just return true in here. Actually no, we don't use the arms, so we return this true. Okay, that's perfect. So now we can process the body. Okay, good. So we can process the body. Let's say var is detectable body equal. Is this a detectable body? Now it returns a true or false. Okay, good. Now we're going to make one more modification. But now we are going to use one more modification. Why don't we have a field in the inspector that tells us which tag do we detect? Yeah, that would be very helpful. Like, instead of hard coding it as player, we can add this ship detector to the player, and maybe the player can detect the enemies. Yeah, that would work. So let's just click the add, then select export, then write var, let's say group to detect equal player. By default, it will detect the player group. So here it is. Let's just save, and now look, it's in here. So now you can customize which tag we can detect with ease through the inspector in here. Okay, good. Let's return the arms for the ship, and let's see. So we have our guard tower, and let's see. So here is our guard tower. It has a script. I want to see the animation of our guard tower again. So here it is. Let's just click. Let's see. So we do rotate. Yes. So I wanted to make sure whether we rotate the sphere or not, whether we rotate the arms, these arms or not. I think I'm going to keep them. But I'll give them like a unique color. So I'll select this one. Surface override. Click new standard. Let's see. Which color should we choose? Let's just go with, I don't know, pink. Yeah, pink is looking dangerous. So we're going to pick this. So we are going to pick this color. We can right click, select copy value. We can come here. New standard. We click on this one. We go to the albedo. We right click, paste value. Perfect. Let's see, can we change the color of the light as well? Yes, we can. So let's click, paste. Good. So now our light is also pink or red. I'm not sure what color is that. Okay, so let's see. There we go. So that's like a much easier and better detection. So, I think it's very quick. Like, gameplay wise, it is very quick. Like, this detector is very quick. So we should probably make it slower. So let's make it slower. Actually, let's make this bigger. How can we make this one bigger? Let's think a little bit. It's actually very simple. You go to the shape. Where is it? There's the shape. You come here, you click make unique, and then you expand the size. Let's say, I don't know, 4 maybe. And then you go to the mesh instance, and then you come here, and put 8. Let's put 8 in all 3 directions. Perfect. So now this tower is quite large, and I don't think we actually need this. So let's just keep it like this. This one should look better now. So let's see. So yeah, this definitely looks better. Let's make the light somewhat stronger as well. Energy. Actually, no. Let's just choose range. Let's make the range somewhat larger, like 10. Let's see how it's going to look now. Yeah, the light is definitely looking a little bit stronger. Let's make it, I don't know, 8. Save. Let's go back. By the way, something very cool about Godot, you can see I'm editing this while the game is running, and the light got weaker. Let's just put 12, save. Yeah, now it's good. I'm liking this color, so I'm going to keep it as 12. Now we have this weird glow thing, but that's something for later. Let's just leave it aside for now. Okay, perfect. So that's very good. So now what is it that we need? We have our enemies. Which can detect the player, and let's remember, go to the ship detector, return can use arms. And for the guard tower, if you want to keep the can use arms to true, that's also your choice. But yeah, I'm going to leave it as true. So let me just close all of these. For example, I want my enemy ship to be able to move between different points. And let's say the enemy ship is here and we want it to move to the player. We want it to know that it should basically move like this to avoid the wall, then move here, and then avoid these rocks like this, and then move forward, and then reach the player. So we want the ships to be smart. We want navigation. So let's do something really cool. So we're going to create a new empty node. Let's search for something called navigation. There we go. So we have, if we write nav, you will see we have so many, like we have so many nodes. Like, which one should we choose? Let's just choose a 3D navigation region, which will define an area where we can walk. Basically, if we click bake, like you can see, it needs something and it's not working. Why is that? Let's click here. A navigation resource is needed. So let's just come here, click create, click new. Let's click. Okay, so it's now throwing an error here. It's saying like the geometry is empty. That's weird. Like the level is not empty. Let's think carefully. This is our environment, okay? This is our navigation. All we need to do is just put it in here and then just do this, and there we go. So let's look. Now we baked all walkable areas. So this area like this is not walkable. This area is not walkable, but in here it's walkable. We can walk, we can do things, and so on. And apparently we can also like walk on the very top of these rocks, but that's like a place we shouldn't really reach. Okay, that's good. So let's just close this. However, let's say before we continue, let's say your ships have like are smaller. Let's say your ships are smaller. So let's say we have a very small ship and it should be able to walk like this. So how can we fix it? Well, it's really simple. You just click on this resource, you go to agents, and there you go. Now you can define the radius and the height and the slope that your units can walk into. Let's say we have a hill that's going upwards, and if it's an angle larger than 45, then we can't walk. But if it's lower, then we can walk. But like, yeah, our level is flat, so we don't really care about that. Let's keep it as 45. But let's say if we want to make the radius as 0.2, and let's actually, since we don't use angle, like since we don't use elevation or ramps, then let's just put this max slope to 10. Let's click bake again. See, now the navigation mesh is actually cleaner, but it's like it's almost climbing up here because we just changed the radius. So for us, let's keep the angle low and let's just keep the radius as 0.5, and you can see this works perfectly, and that weird corner in here that was at the top of the rocks is now gone. And yeah, it looks like let's just see how large is our ship. Let's enter the ship. Let's see its collision shape. So the size of its collision shape is actually 1. So yeah, it's 1. It's 1. So yeah, when you put it to 0.5, it's going to be like this. And for the y-axis, it really just doesn't matter. Let's move it up a little bit. And for the z-axis, it's this long. So yes, this is looking like a far better collider box. Perfect. Let's just save. Let's go back. Oh, this was actually our player ship. My mistake. I think our enemy ships is there. They are. And let's see their collision shape. And it's 0.3. Yeah, so they are actually a little bit smaller. In any case, that's fine. Let's just continue. Now we want our enemies to move. We enter our enemy scene, and then we need to do something. So let's just think about it. What is it that we need? Do we need this? Let's see, what is it? What does it do? It says it's a 3D agent used for path finding while avoiding obstacles. Perfect. That's exactly what we need. So let's just add it. And good, it doesn't have any errors. and it has some avoidance and some other cool features. We don't need the debugging for now, but let's just see. It has a height, like how long it is. Let's see. Let's enable the avoidance. Let's just make the height, like how high is it? I think it's like 1 unit, so that's fine. And the radius, like 0.5, you saw it there, and yeah, 0.5 is good for us. And I think so far so good. Let's see, path desired distance, and you can see there is the slot for other. Okay, good. Now let's go to our ship at the very root, which is our ship. What is our goal? Like, we want our ship to move while avoiding obstacles. That's all we need. Let's say we want it to follow the player. For now, it's going to follow the player. Later on, we're going to make it patrol. But for now, let's just move towards the player. So we need to find the player, and that's how we find the player. Like, you already know how we're going to find the player by now. Like, we will use the group player in the physics process, which is like the fixed update. We need this navigation agent. Oh, the name is very long, so let's just call it agent. We need this navigation agent to basically find the path to the player. So agent dot I don't know what, like, it has so many functions. How can we know what to do? Well, it's very simple. You hold control, you click here, it opened the documentation. It opened the documentation. And if you click on the online tutorials, you can see how to actually use the navigation agent. So that's perfect. But like a useful thing you can always do, you basically always, when you meet a new class that you don't know what does it do, you go and search through its properties. That's fair. So let's look at its properties. So apparently it has a velocity, which is similar to our character 3D. That's good. And it uses avoidance, like it has a radius. Let's look at the functions. Target position. Yes, it's not a function, it was a property. I was looking at the methods, and sadly, apparently, it's the target position. So we need to tell our navigation agent where do we want to go. So let's say target position. Where do we want to go? We want to go to the player. So that's very easy. So player dot global transform dot origin. That's the position of our player. So let's just hit play, and you will see that absolutely nothing has changed. Now that's somewhat of a problem, but really it is not. Like, it's a bit different. So in Unity, if you ever used it, the moment you assign the agent like a target position or destination, it starts moving on its own. But in Godot, it's a little bit different. So let's go in here, let's go to the node. If we click on signals, let's see, velocity computed. Let's remember for a little bit. Like in here, we have a velocity property. Let's see, this is the velocity. So this is the velocity. So basically, when we calculate, like when we want to move to a target position, like the agent will calculate some velocity, and all we need to do is just to use that velocity. Okay, so how can we get this velocity? There are a bunch of ways. The easiest way is to simply use velocity computed. Let's double click on this. Let's choose the enemy ship, and there you go. We have a new function that was created. It's called, like, it's connected from the agent to the enemy ship, and yeah, we just need to move now. We need to use this safe velocity to move. How can we do that? Very easy. So let's just velocity equal safe velocity. Okay, so this first velocity variable comes from character body 3D. This safe velocity variable comes from the navigation agent, which is what tells our character to move. So let's see, print the value. Let's see what is the velocity that we are getting. Oh, so that's the issue. So apparently the velocity that we get is 0. Let's try to move. Oh, okay, that's quite interesting. So we can't get any velocity. Nothing is changing. Well, because I forgot something essential. How does this character body moves? You need to call move and slide like we did. Yeah, that's all you need. Oh, now we are getting an error for some odd reason. Okay, so in here we do assign the position, okay? But like you can see, the velocity is always 0 and we need some more modifications. So the navigation agent will create a path, okay? It will only create a path. So how can we do that? Like we assign the position and we use the safe velocity, but the problem is the safe velocity is always 0. So let's just fix that. Like let's say if safe velocity equal vector 3.0, then we can't really move, so we don't want errors, so let's just return basically. And there we go, we have no more errors. Okay, so we assign the position and we get a velocity of 0. How can we fix that? Here is the thing. So the navigation agent will give us a velocity, okay? But like it will actually give us a path. So let's find the next position that we want to move towards in that path. This will be very simple. You would say agent dot get. Like we can get the entire path, but we don't really care about the entire path. Like the entire path is just a vector 3 array basically. But what we actually need is the next path position, like the next position that we want to move to on the path. So let's say future position. This is the future position that we want to move towards. Now let's find our current position. How can we find our current position? Very simple. Like my position equal global. There is global position, but you can also say global transform. Whoa, not global translate. Global transform dot origin. You can also say global position, and that works, and that's fine. Okay, so do you remember how we used? Do you remember in the ship detector how we used this trick where we created an arrow through math, where we basically, yes, there it is, the displacement. Now we need the same displacement thing, but not towards, but we want it towards the future position where we want to move to. Not towards our current position, no. Not towards the player directly, because if we move towards the player directly, we may hit some obstacles. No, we want the future position. This will give, like this function, calling this line will create a path in the navigation agent. This line will utilize the next position in the path. Okay, this will basically utilize the next position in the path. So next we need an arrow towards the next position that we want to move to, as follows, like the future position minus my position. That's essentially what we need. Now we go to the agent and say set velocity, and you would say set velocity, and it needs the velocity. Okay, but what is the velocity? Like this will send us the entire movement, the entire displacement, but we don't want that. We want like the speed or the velocity. So let's just do export move speed. Let's say the move speed is like 5, for example. Okay, so what we can say is as follows: var direction to move to equal displacement dot normalized. Do remember, this is just some mathematical operation. In here we created the arrow. In here we turn the arrow into a direction. This is just some vector math basically. In here we turn the direction into a velocity. How can we do that? Var new velocity var, actually no, new velocity is a bad name. Let's call it velocity we wish to use. This is the velocity that we wish to use, okay? This is the velocity that we wish to use. And it's going to be direction to move to multiplied by the speed. Now, feed the velocity into the agent. And now the agent will give us the proper velocity. This is somewhat of a complicated process. So, oh, I forgot to put a var in here. Okay, good. Now we have the var. Huh. Oh yeah, I called it move speed, not speed. Okay, so move speed. Okay, good. Now we need to assign the velocity we wish to use. Why is that? Like, let's say there was an obstacle in our way. Let's say there is another agent, another ship, okay? So the navigation agent will take the velocity we wish to move to, that is based on the path. It will take it, it will process it, it will ensure it's valid. Like if there are some obstacles in our way, it will modify the velocity, and in here we receive the modified velocity. Let's hit play. Look, perfect. So now it's moving. And actually, let's just be very careful. So look, let's see. It's moving. So yeah, that's just very good. So let's just go there. See, it doesn't. Oh, it apparently got stuck and there are a bunch of errors. Let's just see what we have. So let's think a little bit. Why did it get stuck on this? Let's see. Why did it get stuck on this? Well, let's just take our unit. There it is. Let's just move it here. So let's think. So here is the sphere, like the capsule, and let's look, where is the collision? Where is the collision with this? This is the collision with this. Yeah, so that's the collision. So like when it's here, this capsule will collide with this square. It might be hard to see in the video. I hope it is. So there's this square. So yeah, it's colliding like this and it can't move. Okay, so it can't move. So that's the problem. So how can we fix that? The easiest fix is to basically like prevent the ship from colliding with the environment. Why is that? Like, doesn't the ship need to collide with these rocks? No, it really doesn't, because this area is not walkable at all. So because we are using the navigation agent, it's not going to touch it at all. So yeah, it doesn't really need to hit the environment at all. So what do we need to do now? Let's go inside of our ship. Let's expand collision. And you can see we have layer, which is where this object belongs to. And we have this mask, which is like with which things does this collide with? Like with what does it collide with? So currently everything is on the first layer. Everything is in the first layer, so everything collides with each other. Now here is the thing. We don't want this one to collide, like we don't want this ship to collide with the environment. So all we need to do is click like this and it will no longer collide with the environment. Why is that? Because if we go back to our level and see the environment, you will quickly see that, oh, not the environment, but like the... So if we go to the environment collisions, you will see all our collisions are inside of the first layer. Our collisions belong to the first layer. But our ship, let's look at our ship, it doesn't collide. This one, the mask, basically tells us who do we collide with. And this ship doesn't really collide with anything in the first layer. Okay, it doesn't collide with anything in the first layer. So if we now hit play, let's see. Okay, so our ship is moving and it's avoiding the wall. Like it's not the wall, I mean the rocks. So, but you can see sometimes it does intersect with the rocks. And how can we fix that? The answer is very simple. We just need to make the unwalkable area somewhat larger. So we come here, we go to the agents, give it a radius of 1, bake. Now it's much bigger, like probably way too big. Let's see now. Now it's going to be much harder. Now it's oh, it got us. So now you can see it's much harder for this one to collide, like for this ship to collide with things. That's perfect. Let's now let's now collapse this. Let's collapse this one. Let's go to the enemies. Let's open this enemy. However, if you go to the errors, debugger, and then debugger, you will note many errors. And like the first one is the most important. And basically, so here is the problem. Okay, so if we go into the debugger, you will find a bunch of errors. And this is the most prominent error. And it's basically saying the navigation server is not ready or whatever, but like why? Okay, so why does this error show up? Like if we go to the debugger errors, you will see this error. How can we fix it? Well, basically this navigation region will get ready, like will be ready to be used only after the first physics frame has been finished, okay? But when do we move? We move after, like we move right away on the very first physics frame. So all we need to do is just create a very small delay. The first time this function get called, we do nothing basically. So var is first call equal true. And then we say in here, if is first call return, and then say is first call equal false. So this is not the first call anymore, so now we can start, and there we go. There is also one more thing we need to do. We need to make sure that we don't keep trying to find like a new path or new movement when the movement is done. So how can we do that? It's very easy. If agent dot is navigation finished, return. Okay, so if we have finished navigating, like we are not on the target anymore, then we don't need to really do anything. So yeah, that's all that we need to do for the movement. Now we need the ship to rotate towards the place where it's actually moving. So how can we do that? Again, very easy. Look at and the target. Where is it going to be? My position plus velocity we wish to use. Now it's going to look towards the place where it is going. And apparently, as you can see, the ship got flipped. And how can we fix that? Very easily, we can fix it using the displacer trick. Let's remember the displacer trick. So you create an empty node 3D, call it displacer. You would put these two inside of it, and finally all you need to do is just rotate by 180 degrees. So it was like this, now it is like this. Actually no, you can do it the other way around, so let's just do it like this. So the displacer is like clean, we don't use the displacer, we modify the things that are inside of it. We just hit play, and there we go. So we can see that our ship is, the enemy ship is actually chasing us. And that's perfect. Now we don't want the enemy ship to actually chase us. We want the enemy ship to move, like to chase us when it detects us. Otherwise, we want it to move towards some patrol point, basically. So let's see and think. How can we do that? This will be very easy. So we do export var, and then we need like a bunch of points. Okay, we need a bunch of points. So let's call them patrol points equal. Like what is it going to be? It's going to be like null. Like we want a group of points. How do we create a group of points? Now take a look at what I'm going to do. So patrol points, and then here I'm going to say dot like this, and then I'm going to say array, and in two brackets I'm going to say node 3D. Actually, let's choose marker 3D. Let's choose marker 3D. Oh yeah, like we gave it a null. We shouldn't have done that. Let's just do it like this. There we go. Now if you click on the enemy ship, you see we have an array. We can add a bunch of elements as well. So let's just save. return to our level. Let's select our ship. Where is our ship? Like, this is our ship. We want it to go like between certain points. Let's just create a new empty node and call it ship 1 patrol points. And then we're going to create a marker, call it point 0. And then we have point 1. And let's put our markers in some sensible positions. So that's the first position and that's the second position. So we want our ship to move like this between these two. So we want our ship to move between these two markers. That's all we need for now. Let's just make the marker a little bit further away. There we go. So we want our ship to move between these two markers. How can we fill these markers? You go here, you come here, you fill these, you take this, drop it, take this, drop it. There you go. Our points have been filled. Like, now our points have been filled. Now, if we go inside of ship 1 once again, now let's think, where do we want to move? Do we really want to move towards the player? No, we don't want that. We want to move towards the current. We want to move towards the current patrol point. So let's see. We want to create a variable current patrol point. Actually, let's call it like this. Current patrol point patrol point index is 0. That's perfect. Now, where do we want to move? Like, where do we want to set the agent? Oh, let's remember. We add this line because the navigation region takes time to prepare itself. Basically, that's why we have it. Okay, now, what else do we need? Like, we need to move towards, not the player, towards the marker. So let's see, where is the patrol point? Here are the patrol points. And then we add 2 square brackets like this and put our current patrol point index. Now let's just hit play. Oh, and we have an error. So why is that? Because we get the node, but we don't want the node. We want to move towards the position. So global position. There we go. Of course, you can use global transform.origin as well. So yeah, we used that like throughout the video. So let's just use it. Okay, so something weird is happening over here. Let's ignore it for now. Let's just ignore it for now. We're going to print one message, okay? Once we reach the target, we want to print a message. Let's see, how can we, where do we know whether we reached the target or not? This function, okay? We have reached our target in here. So, what do? We do as follows. We will say current patrol point index equal current patrol point index plus 1. And let's just hit play. Good. Now you see, like you saw what happened. Let's see it really quickly. So it's moving towards a point and then we have a crash. Why is that? It says invalid index at point 2. Oh, and that's the problem. So we keep increasing our current patrol point index like infinitely. So, and on how many points do we have? We have 2 points. This will be point 0, this will be point 1. Once we get to number 2, we will get an error. So how can we fix it? Again, very simple. If current patrol point index is greater or equal than all of these patrol points, like their size, then current patrol point index is 0, which is the first point. Let's see. Let's just observe and see. Perfect. So it's moving between these 2 points. Okay, that's very good. But now we reach our next goal, which is once we cross our path, like once our path crosses, okay, so once our path crosses not our path, once this player crosses the enemy ship, like what will happen, or what do we want to happen? We want our player to act, like we want the enemy to chase the player. So how can we do that? Oh, apparently we have a bunch of errors. So the node origin and target position are like they are in the same position. So that's a problem. So how are we going to fix it? Well, it's in player ship line 30. Oh, okay. So we need, like we said, transform.origin. We should have said global transform.origin. Let's hit play. No more errors, as you can see. So yeah, we had a bunch of errors, but now it's clean. Okay, good. So what we want now is once we cross this, we want the enemy to chase us, basically. So let's go back inside of the enemy ship one more time. How do we know when the enemy has crossed, like we are inside the player? How can the enemy know when the player is inside his radius? Now that's going to be interesting. Let's think a little bit. A new concept that we need to use. So let's go inside of our ship detector. Let's see. Here's our ship detector. If we click on it, we go to node, you will find it has some signals which are events, and we use this event to basically tell us once a body has entered, like once a body did enter the area 3D, and then we do some complex arm test, and then we return the value. What if for this ship detector, which is in here, we create a new signal or a new event that basically connects with the enemy ship? Now that would be very interesting. So let's do it that way. So signal on detected ship, and then we want to say the ship that we detected. Now, if we save and then go back on this, you see we have this new like category, and if we double click on it and connect it to the enemy ship, now we have a new function. Let's just say print ship.name. Now, if we play the game again and just move here, yeah, so nothing has changed at all. Why is that? Well, we did define the signal, but we never called this signal. So how do we call it? Very simple. If is detectable body, then you copy this, and then you write emit, and then you feed it the ship, or in this case, it's this body. So it's going to, yeah, you feed it here. Now let's see if we enter this. Okay, look here. So, player ship. If we come, now look what happens if we come from the back. Let's wait while it's gone. If we come from the back, nothing happened. If we come from the front, we are detected. Perfect. We are detected within the arms. Perfect. Okay, let's go back to the enemy ship. So now we know we detected the ship of the player. So what are we going to do? Well, we want to modify this function right now so that we actually move towards the player instead of the patrol point. So now, like, this is a very good time to extract this code. So how can we do that? Well, we can do the following. First, let's start by extracting the movement code. Entirely in a new function. Let's see. So here is the new function, func underscore move ship to point, and in here we just need the point. Okay, and now we should just take all of this and then do this basically. Now you need to be very careful. What we have in here, we shouldn't move directly. We should not move directly towards the point, okay? We should move toward, like, we shouldn't move directly towards the patrol point. We should move towards this point. So let's do this and do it like this. So yeah, now we just move towards this point and that's it. We don't care about anything else. So let's go back to process and let's see. So we have this line var patrol point position. Patrol point position is equal to this line. Now we just say move ship to point which is the patrol point. Let's run the game. Okay, so now the ship is moving again. That's good. But we want something unique. Let's see. In here, we want to return a false. And in here, we want to return a true. That means we have moved. Oh, also, this might cause an error. What if the velocity we wish to use is 0? Well, then we need to do the following. If velocity we wish to use equal vector3 dot 0, then I meant doesn't equal 0, then we can rotate. If it's not 0, obviously you can say dot length. You can say dot length and greater or equal than 0, but that's an alternative way. Like, I'm going to use this way basically in this method. So yeah, two different methods. Like, if you remember, inside of the player shape, we use this. Inside of this, we use doesn't equal vector3.0. Both will give us the same result. In any case, now we return false, we return true. Okay, so let's just do something unique. Let's create a bunch of states for the enemy. Like, we have two states, patrol and the, so we have the patrol state and, okay, so now let's just refactor the code a little bit more. Let's extract this code, which is related to the patrolling. This code is related only to the patrolling, so we don't need to do it. But the rest of the code is related to the movement, so that's good. So the code that is related to the patrolling, we're gonna put it here. And I'm going to do the following. If not, so if we failed to move, when this one returns false, then we will do this. Okay, perfect. Now let's look closely at this movement. This movement is related to the patrolling, and this, like this one, basically picks up the patrol position, and now we try to move the ship towards the next patrol point. And if we don't move it, we change the patrol point, and that's it. So what is this? This is the patrol behavior. So let's also create one more function and call it func_patrol behavior. And now we will just take this code again and just put it here. There we go. Now we can say patrol behavior. Let's just hit play. Good, nothing has changed. Now what do we need? What if we create a new function and call it func_chase ship behavior? Actually no, chase detected ship behavior. That's it, that's all we need. So now how can we do that? Well, let's see. So let's first comment out the patrol behavior, and instead let's just use this. What is this going to do? Well, we want to chase this ship that we detected. Like, we have access to the player, but we don't want access to the player. No, what we want is chasing the ship that got given to us in here, that got given to us in this area. Okay, so how can we do that? Very simple. First, we need to cache this ship. This is caching basically. So var detected ship equal null. And what is the ship going to be? So where is it going to be filled from? Detected ship equals ship. That's it. So let's chase this ship that we have detected. So how can we do that? Very simple. Move ship to point detected ship dot global transform dot origin. You could use in here. Actually, let's just use global position directly, okay? Just because we haven't used the global position at all previously. Oh, okay, so there is an error here which says detected ship is null. So we don't have a detected ship, and that's a problem. So yeah, this is the error. There it is. So how can we fix that? Very simple. If detected ship is null, we return. Let's hit play. Good. Let's enter. Oh, nothing is happening. Why is that? Because we care about using the arms. Let's ignore the arms for now. Let's see. Oh, okay. So now it's going to chase us to the infinity, basically. Like, it's going to keep chasing us, and yeah, there it is. It's just chasing us infinitely, and it avoided the rocks, and perfect. Okay, so here's what I'm going to do. I'm going to give this like a speed of 3.5, and I'm going to call this patrol speed. And oh, let's see, now we have an error in here. So let's also put it in here. Move speed. Now we're going to get 2 more errors. There they are. So chasing. In here we use the patrol. So let's just use the patrol speed. So basically the new function that we created, which is move ship to point, like it needs to know the speed. It needs to know the speed. And in previously we had just one global move speed. Now we're going to have multiple move speeds. So now we have chase speed is gonna be 5.5, for example. So in here we can just use chase speed, and let's just hit run. Let's do it. Okay, so it's chasing us. It is chasing us. I think 5.5 is way too much, so let's just go with 5 and 3.25. Okay, good. So let's look now. If we do this, we go back to the patrolling behavior. Now what we want is that once this detects us, we want it to chase us. So how could we do that? Well, it's actually, we need to switch between these two behaviors, these two functions. That's all we need. So how can we do that? There is a very interesting feature in GDScript. It's called enums, okay? So these are basically states. So ship AI, ship state. And we have 2 states, patrol and chase. Now let's create something new. So var current state equals AI ship state dot patrol. Now we can easily say if current state equals AI ship state dot patrol, then do patrol behavior. Otherwise, elif current state is AI ship state dot chase, then do the chasing behavior. Now let's hit play. So we are patrolling. Good, we are patrolling. Now what is it that we need to do? We need to change the current state. All we need to do is just change the current state. So in here, current state equals AI dot chase. Now let's see what we have. So here we go. Let's wait. It detected us and it's chasing us. Let's run away. But like, I think it's very hard if it just keeps chasing us like to the infinity. Why don't we increase the radius? Like, by the way, we will fix that later. This is just simple collision stuff. I mean, not collision stuff. Like, we need to make the ship do something when it reaches the player, rather than you know, hovering over him and then like messing up the collisions. Like you can see, the enemy ship is pushing the player right now. Oh, it pushed us way too far. Anyway, we can fix that later, but that doesn't matter. In any case, for now, our goal is like once the player is out of range, once the player is outside of the detection range, then we want to go back to patrolling state. So what do we need? We need another ship detector. Let's call it, let's duplicate this one and call it ship exit detector. Okay, we created a new detector, and let's remember to remove the connection that we have made. So this one like undetected. Okay, this one is like undetected. We want like something to happen when the ship exits this trigger. First things first, this one shouldn't use the arms, the ship exit detector. And let's see, what else do we need? Let's actually stay in the enemy ship. Let's make it editable. It doesn't need arms, so I'm going to disable the visuals of these arms. And also I'm going to just disable the visuals. Okay, so now we just need basically a bigger sphere where it detects once the enemy exits it. So that's what we need. So let's just see what we have. Like we disabled the arms of the new one. Let's disable the, not the collision shape, but the like detector visuals. Let's just disable them for now. And let's see, how can we make this bigger? Well, it's very simple. You click make unique, and then you just make it bigger. Let's say 3 maybe. Yeah, now let's just make this one as 3. And of course, let's, oh, we can't duplicate, and we don't really need to duplicate it. Let's just enable the visuals. Let's click on this surface override material. Again, make unique. And then just change the visuals, maybe the color. So let's change it to this color, and let's remember to make it like change the size as well. So the size is going to be 6, so it fits the outer sphere. Okay, let's just disable this. And now let's look at this script, which is for the ship detector. So what does it do? It only checks once we enter, but we don't care about the entry. We care about the exit for this exit detector. So we go inside the ship detector, we click on it, we click on the node, and now we're going to use body exited. So body exited, and let's see, we connect it with ship detector, and we do this. Again, we do this. So now we have this on ship body, like on body exited. Now it's going to be very similar code. First, let's process the body that exited, and then if is detectable body, we need to emit. We don't need to emit like if we detected the ship. No, we need to detect whether the ship has left, basically. So just say signal on left, on ship left, and let's feed it the ship. So on ship left dot emit, and then you give it the body. Come on, now let's just save. Let's go back in here. Now let's come here. See, we have undetected ship, and in here on ship left. Now of course, like it would be best practice if you rename this one to so that it's called on ship entered, but I'm going to leave that as an exercise for you. I'm not going to do that. So on ship left, connect it with the enemy ship. And now let's see, so where are we going to put it? Let's put it in here below the detection directly. So what do we need to do? If the detected ship doesn't equal null and detected ship is the new ship that left this sphere, then simply what do we need to do? Well, it's actually very simple. So first we checked whether the ship like exists or not, whether we are detecting a ship, and then whether the ship that we are detecting is the same one that we are no longer detecting, and we just need to update our data. So detected ship is null, we are no longer detecting it, and then current state is going to become again as patrol state, and that's just perfect. Let's also remember something. We also need to check whether we are in the chase state or not, because we don't care if we are not in the chase state. So if current state equals AI ship state dot chase. So if we are chasing and there is a ship we are chasing and the ship is the same one that left this sphere, then we go back to patrolling. And now in here we need to do something similar. What if like we detect a new ship and we are already chasing someone, we're not patrolling? So what do we need to do? If we keep it like this, it will update the target and chase the new ship. So it would continue working. So I'm going to leave it as it is. Let's just hit play. Let's see, it's detecting us. Let me run away. Okay, so I ran away and it worked. Run away, it worked. Perfect. But like, let's see, it would be useful if we disable this visual, this green sphere, and enable the orange sphere instead. So how do we do that? Very simple. We go to the ship detector scene or prefab, then we create some function and call it func enable visuals. Oh, that's some poor spelling on my end. Okay, so enable visuals, and then we give it a pass, and then func disable visuals, and then we give it another pass. Let's see. What are we going to enable or disable? We are going to enable or disable this one, the ship detector visuals. So drag it, drop it, put a space, and ship detector visuals dot visible equal true, dot visible equal false. Save, open the enemy ship, and now let's see what we have. So we are in the enemy ship. Let's go back to the enemy ship. We have these two detectors. Let's just grab the first detector. Let's just grab the second detector. And now ship detector, if we are chasing, then enable visuals. Oh, actually no, we needed which one? Ship exit detector dot enable visuals and ship detector dot disable visuals. Perfect. Now we just need to reverse the statement in here. So in here we disable, and now we enable. Now let's just hit play. Let's see, come on, get closer. Okay, it's chasing us. Let's run away. Okay, we ran away and it's back. Perfect. That's very good. Now that's some sort of nice visual feedback that we can have. Okay, good. So yeah, I think our ship is basically done. Let's see, what else do we have? We have this group that's called, okay, good. Okay, let's go back to the let's go back to the tower. Let's pick up where we left off on our tower and finish our tower off. So let's just put the tower in here. Now what is it that we want? We want that we want it as follows. So first, let's just take this ship that is disabled and does nothing, and let's put our guard tower in here. Let's just rotate it a little bit. The guard tower should use the arms. Where are the arms? I can't see. Oh yeah, there are the arms. Okay, good. So let's see. So here is this ship tower, guard tower. Let's see. Okay, so here are the arms which help us like a little bit. Now what is it that we want? Like the guard tower is doing nothing. Let's just print a message when the guard tower detects us, and once we are outside of its range, So what how can we do that? Like just like we did previously, we come here, we go like inside of the ship detector, and then we click on detected ship, we connect it, and now let's just print we have detected a ship. We detected a ship. That's all we need. So let's just do it like this. Did we print something? Yes, we detected a ship very easily. Okay, so what do we need to do if we detected the ship? So if we detected the ship, we want to call all other enemies and just make them chase the player. Like, yeah, so I'm going to make the tower to be a game over type of thing, where if you are seen by a tower, it's over, it's game over, and all enemy ships will contact you. So, like, they will try to catch you. So, how can we do that? Get tree.get nodes in group enemy. So now we have var all enemies equal this. Okay, good. And what else do we need? Let's go. So enemy ship. Let's create a new state. Call it frenzy chase, which is triggered by the triggered by the guard tower. So let's just see, where are we going to create this function? Let's create it here. Func enter frenzy. So let's just enter the frenzy, and yeah, let's just enter the frenzy. So what does this enter frenzy state do? Basically, current state equal AI ship state dot frenzy chase. And of course, in here, you just need to do the following. Elif current state equal AI ship state dot frenzy, then frenzy chase behavior. And finally, we just need to create the frenzy chase behavior. Func underscore frenzy chase behavior, and then we have a pass. So what do we do in this frenzy chase behavior? Well, we chase the player infinitely until the game is over. So let's just see. We want to find the player again. I guess we needed him after all. Player equal get tree.get first node in group of player. Okay, good. So what do we do in here? Like move ship to point. Move ship to point. Now, which point is it? It's the player dot global position. Now, if we hit, oh yeah, we need to feed it the speed. So which speed are we going to use? I'm actually going to use the patrol speed. Like, I don't want them to chase the player very quickly. I want them to like take it easy. So yeah, I want them to take it easy and like chase him slowly, just so that like the player has a chance to win. Oh, we are still printing the message, but we are not chasing at all. So how can we fix that? Very easy. Guard tower. We have the enemies, but we don't call the function. So for e in all enemies e dot. Now what is the function called? Let's see. Not frenzy chase behavior. No, we created this, which is called, where did it go again? Enter frenzy state. Okay, good. So enter frenzy state. Do this. Let's do this. Let's just enter. Okay, so now just take a look. Now this enemy is just going to keep chasing us basically forever. Actually, I'm going to change it a little bit. So I'm going to add a timer where if the enemy simply doesn't detect us, so if the enemy doesn't detect us within like let's see, come on, come back. Oh yeah, like they don't he currently doesn't use the, come on. So yeah, okay, so I have an idea. I'm going to add a timer for the frenzy where they will chase us for like, all enemies will chase us for like 3 or 4 seconds. And then once they do that, like once the time is out, they will simply like return to their patrol state if they haven't chased us yet, basically. So let's see how can we do that. So let's go back inside of our enemy ship. First things first, we are going to create a timer. So let's just timer. So on timeout, let's see, let's call it frenzy state timer. Timeout enemy ship. Okay, so frenzy have timed out. So what do we do? Let's just go back to our patrol state. So we just take this, we go back to this state basically. And let's also remember, apparently there is a bug in here. So as you can see, I forgot to add indentation in here. So let's just do that. And so the second thing that we need to do is to actually make sure the visuals are up to date. So once we go inside of the, oh, we don't want to go inside of the frenzy again, we want to go inside of the patrol. So in the patrol, we make sure the ship exit detector is disabled in terms of visuals, and the ship detector is enabled in terms of the visuals as well. So okay, good, but we need to actually start this timer. So let's just drag it, drop it. Oh, I dropped it in the wrong place. Let me just add a space, drag it, drop it. Okay, it worked. That's perfect. Now, where is the frenzy state? So here is the frenzy state, and now we need to start the timer, and we also need to configure the timer. Now it's 1 second. Let's make it 3.25. Let's make it a one shot. And let's see, what else do we need? Oh yeah, now we need to remember to stop this timer. So let's say like we left the frenzy state either by entering the chase state or by going back to the patrol or whatever. So we need to make sure the timer is stopped. So how can we do that? Very easy. Again, the frenzy timer, frenzy state timer dot stop. That's all we need to say. And so let's see, where do we enter the frenzy? Where do we enter the normal chase state? We enter the chase state in here. Let's make sure we stop the timer. And in here, let's make sure we stop the timer. And there we go. So, and let's, like, this one is far from the other functions. So let's just make it a little bit closer. Good. So now let's start the game. Oh, so there is a bug. Let's just hit play. There we go. So here it is. So let's see. So it's chasing us and it should run out of time. It ran out of time before reaching us. So it went back to patrol. Now let's see. Let's enter again. Okay, so it's running, and it almost found us. So that was dangerous. Okay, good. So now there is one more bug that we need to fix before like we go back to actually designing our level in a more better manner. Let's say we entered this, okay? We entered this. Now we're not detected. What if we just move like this? See? It doesn't update whether we are detected or not. It only tests for the detection when we are from the outside, and then we come inside in the right area, like this. So now it's going to chase us. Oh, it found us. So now we just need to run away in the normal manner. In any case, so we need to fix that bug. So where does that bug exist? You might think it's on the guard tower, but no, it's on the ship detector itself. So here is the processing. This is where it processes, like this is where it finds the body. So how can we fix this bug? We want to keep checking and processing the body like for as long as it's inside of this sphere. Once it leaves, we want to stop checking it. So something we need to do continuously. What does that mean? That means func_physics process yet again. So let's see. We're going to create. Oh, by the way, signals should be at the very top. That's a good convention. And in here we have the. There we go. Let's put our variable in here and say all bodies inside equal an empty array. That's it. Now you can like do this and then put an array like this, and yeah, it can work. So let's just do it that way. So all bodies inside, if it's detectable, let's see. So all bodies inside dot append and body. We added the body, but we need to make sure that like the body doesn't already exist inside. So if all bodies inside dot has body, then return, because we don't need to add it. Okay, good. Let's see what do we have in here. If all bodies inside dot has body, then return, but we need to add a not in here. So if this array does not contain this body, then we return. Otherwise, we need to remove the body. All bodies dot erase and the body. Now it's deleted itself. It now, like, the list is empty. Okay, so we have this group which contains all the bodies inside. Actually, let's think a little bit. Do we really always want to check for all bodies? No, we only want to check for the bodies that failed the test, like they might become true in the future. So let's just return in here and yeah, so we will only return from there, and that's it. Okay, good. So in physics process, we will go for B and all bodies inside. If no, there is no need for an if. Or actually, let's do it an if way. So if process entered body, if process entered body B, if process entered body. So we go through all the bodies that are inside that have already failed, and we try to process them. If we process them successfully, then basically we need to remove them. So let's see, remove B. And then what else do we need to say? We need to say that we detected them. So undetected ship dot emit B. Okay, perfect. Let's see the tower thing now. Oh, that's bad. Let's see. Actually, yeah, let's just go outside. Oh my god, it's still detecting us. Okay. In any case, so we are in here. Let's see what's going to happen. I want to go outside. Okay, so let's see. So I'm avoiding it. So now let's see. What happens if I enter this red region? Look, it started chasing us. Now let's see. Oh, yeah, I was a little bit too close, I guess. So, okay, so let's just do a quick test. So here I am. Now, what happens if I cross the red area? Let's see. Previously, nothing happened. Now, this ship should start chasing us. So let's see. Oh, okay, the ship is chasing us. And it got us almost. Okay, good. So now that have solved almost all the bugs that we have. Now we need to add a way for the enemies to actually kill the player, because now yeah, nothing happens other than messing up the collisions, and like we want basically to show a game over screen. So let's think. So we are almost done. Let's think carefully about how can we do that. Well, again, very simple. You go inside of the enemy ship. You add one more ship detector, and remember, like, it needs to be inside of the displacer. Here it is. Let's call it ship kill detector. And remember, go to the nodes and then disconnect this. And now we need to connect it again, basically. Now it's connected to this function. Like, this function will basically kill the player, basically. So let's see, where is this ship? So let's see, where is this detector? So let's make it like editable children, and let's see, ship visuals again, surface, make unique, and let's make it full on red now. Here it is, like very red. There we go. Okay, and we need to make it very small, or like much smaller at the very least. So let's make it with the size of 1, 1, 1. That's way too small, like 2, 2, 2. I think that's fine. Okay, good. So what else do we need? We don't need the arms at all. And in here, let's make sure the arms are disabled. And let's enable the arms for the patrol, like the green detector. So now we have our kill detector, which is this third detector thing. Oh yeah, we need to update the collision shape actually. So we come to the collision shape, again, click, make unique, click again. So 0.5, oh no, not 0.5, I meant like 1. Yes, so now it's touching the player. Okay, so if the ship like touches the player, this clause the player will simply lose. So let's just go to this script, enemy ship. How can we make the player lose? Let's think a little bit. What controls the winning and losing? Well, it's the game controller. So get3.get first node in group game controller var game controller. So now we have the game controller inside of the enemy. Now game controller dot, let's see, what functions does the game controller have? It have like is game over, like has delivered keys, pick key, and then we check on the key picks and that type of thing. But yeah, we don't have lose game, so let's add it. So func lose game pass. Okay, so what do we need to do? Let's go inside of this one. Let's create a you lose label. As simple as that. So you lose panel, and in here let's just change it to you lose, and let's just go to visibility, give it like orange, red, something like that. I'm not sure, like let's give it this pink. Okay, good. So you lose panel, there we go. So you lose panel, like it starts disabled. And what else do we need to do? Like you lose game, so lose game dot visible equal true. And what else do we need? We need to restart the game, so we need that timer. I think we had a timer in here. Yeah, there it is. Sure, it says like you win timer, but like effectively you lost. So, but like, yeah, the player won't see this name and it doesn't really matter. So now we just show the you lose panel. And what else do we need to do? Like we can say var has player been caught equal false. Actually, was player caught equal false. And was player caught equal false. Now let's make it true. Now is the game over? Either we delivered the keys or the player was caught. So let's just hit play. Let's just, oh yeah, we forgot something. So we need, so apparently this state doesn't exist anymore, which is called the interfrenzy state. That's weird. Let's just exit everything. Let's just do this. Let's just check it out. So we need to disable this thing. Yeah, we like disable the visuals of this. Let's just, and we forgot to actually call the you lose function. So game controller dot, what is it called again? I already forgot. So lose game. So let's call lose game. Okay, so now we can lose the game. And what else did we need? Yes, we needed to disable the visuals. We need to disable the visuals of the ship detector, the ship kill detector. So let's just make it disabled by default. And then when do we actually enable it? Let's see. So let's drag it and drop it. Oh yes, this is the correct place. Ship kill detector. Where do we enable it? Well, we should only enable it inside of the chase state. So like here it is, dot enable visuals. And for everywhere else, let's just disable the visuals basically. So disable the visuals. Actually, the frenzy should have it enabled. Am I right? Like, yeah, it should probably be enabled in the frenzy. So yeah, that's it. Let's drag this one as well and put it next to the functions that are connected to the like signals. As you can see in here, we have functions that are connected to signals. Let's hit play. Okay, it's not visible. Let's get here. It should detect us. Okay, it detected us and we lost. And we can't do anything. But as you saw, sure, we lost, but then the collisions still like got messed up. I think it's fine to keep it. We can freeze it, but I think it would be fun for the player to see that they like with the enemy ship sort of dancing like for 1 second and so on. But yeah, I think that's fine. Okay, good. So let's just really quickly design some nice experience. First, let's enable these disabled enemy ships. Let's go to the process. Let's click this. Now it's back to inherit. Now, what else do we need? We need to add some, let's see, we need to add some like patrol points. So yeah, let's just duplicate these patrol points once and twice. Let's put it in here. Okay, so let's put the first patrol point. Oh, let's just add 2 elements, like first patrol point, second patrol point. Perfect. Let's put them in appropriate, like in some appropriate places. So this enemy ship like has these. So where is it? Let's just put it here. It moves through in this corridor basically until here is like somewhere reasonable, I would say. And for this one, this marker, it should be moving like this basically. Okay, actually let's just make it move like this. Okay, good. Okay, so for the second ship, it doesn't have any points yet, so oh yeah, let's just put this one above. So yes, the second ship doesn't have any points yet, so let's just give it 2 points, 1 point, 2 point, and let's see. So where does the second ship actually live? Oh, so yeah, so the second ship is actually here. So let's make it patrol from here to here to here to here. Yeah, this path. Okay, so it's going to need 3 points. This will be the final point. This will be this point. And this will be the first point where it travels basically. Yeah, I think that's going to be fine. Where is the third point? Let's make the third point over there. Good. So yeah, let's see. So the second ship should have 3 points, I guess. Point 3, point 2, point 1. Okay, good. So now we have all of our enemy ships. And we have our guard tower as well. Where should the guard tower live? Let's make the guard tower live here. And let's fix the second guard tower. The second guard tower is nothing more than a model. So yeah, that should be fixed. So let's just drag it and drop it in here. And let's just put the guard tower right here. It makes more sense for the guard tower to be something like this. This is just like level design. Like I think this makes sense. And so yeah, I'm just I will probably speed this up, and yeah, the last leg is actually pointing outside, and yeah, like you can easily fix that. You just click on make editable children, then you go select the correct leg. This is not the leg, not this leg. There it is. You just click on the correct leg and you disable it, and in here it's like essentially the same. So again, editable children, you select the leg and disable it, and finally you just take this, put all the enemies inside. Okay, and let's do one final thing. Let's just come here, like let's so yeah, like as you can see, it's probably like somewhat ugly or hard to see this because of all the green and blue lines. So let's just okay, so now we can just hit save, hit play, and let's just observe. One final change I'm going to make, I will actually change the patrol points for the third one so that it comes actually here as well. So it moves here, 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 like this. That's cool. So let's just update this enemy ship and add the new point, and let's just collapse everything. Let's just save. And so yeah, now we have a fully properly functioning 3D game. You can actually get detected, you can actually lose. Okay, so one final bug I noticed is that if the player gets too close to the enemy from the enemy ship from behind, he will still lose despite being that he was not detected. So how can we fix that? Again, very, very easy. So what we would do is as follows. We would like on ship detector. So yeah, we only check for the, let's check for the state. So if current state equal AI ship state dot patrol, then return. Basically, if we are in the patrol state, then we were not detected, okay? So basically, if the player comes from the back, if the player comes from the back of the enemy and the enemy is still patrolling, that means the enemy didn't see us. So yeah, that means we don't need to make the player lose the game. Another solution is that we can simply go inside of any enemy and then make the kill detector use the arms. So that's like an alternative solution. Like you can use any solution you like. For me, I'm going to use this solution, and this solution is somewhat janky because it will basically check the this solution is somewhat janky because let's imagine the enemy turned around and he detected the player immediately. Now the player won't lose immediately, he will have the chance to run away, and that may be something you want in your game, and it may be not something you want in your game. If you don't want it in your game, you'll need to create an array and check it in the process function. Where is the process? There it is, the physics process function or the normal process function, your call. In any case, let's go back, let's hit play. Okay, so in any case, we now have a completed stealth game that we can play, and we have enemies to avoid that can detect us, and we must run away, and if we're detected, we actually lose the game. Yeah, there you go, you see, they caught us, we lost. Oh, why the game is not restarting? Okay, it just did restart. And yeah, you can use it to just build like a bunch of levels. And sure, it might need some polish. You will need to add more animations, like some particle effects. You will need to make the rotation smooth. Like there are so many improvements that you can make on them. But like, let's look at the positive side of things. Like you managed to build a 3D game within Godot. Like if you knew nothing about the engine, now you pretty much know all the basics that you need to build any game. If you came from Unity, you now have a very large background on all the ways you can like use the core tool set of the engine. And if you never used like any other game engine before, then you are now experienced with building small scale games. So yes, that's it for this stealth based game. We now have a complete stealth game that you can use. You can build games similar to it, just use different assets, and you have your cool own unique game with your own unique twists that you can add on them. You learned navigation, like groups in details, game controllers in more details. You created a basic AI using enum based finite state machines. The enum based finite state machines, it's incomplete to say the least, and it's hacked, and it's not a proper structure, but it doesn't matter. The game works, the AI works, and you can extend it with more states very easily. And that's what matters when you are starting out, if you are new to Godot at least. Okay, so that was it for the game. Now you have a complete 3D game that you can use. You created a bunch of scenes, you created like 2 levels by now, you created a bunch of scripts, you learned about navigation, like 3D rotations, you learned about enemy AI and animation player, and so many other new things. If you are new to Godot, like if you came from another engine like Unity, you now know the core tool set of the engine, especially if you watched like the first video. If you didn't watch the first video, I highly recommend it. It's 1 hour. You make a very quick 2D game. Okay, so one final fix we actually need to make about the system. Basically, in the frenzy state timer, I wrote in here enable, but we should actually disable it. Why? Because once the frenzy timer is out, it will enable the skill detector, but we don't want that. We want this skill detector to be invisible. So let's just disable it instead of enabling it. And inside of the ship, I'm actually going to make one tiny change. I will take the first arm of the, let's do it like this, let's make it editable children inside of the enemy ship, and now we're going to do the following. We will just take this, we're going to take the first arm, and we're going to change the angle to -55, and in here the angle to 55. Okay, so we actually have one more final bug that is related to the game controller. So let's imagine a scenario. Let's say we delivered the keys, but the moment we actually delivered the keys, one of the enemies detected us and he attacked us and we lost. So that's not going to be very fun, and it will register that we lost. So let's make sure that as long as we have delivered the keys, then we can no longer be caught. So how can we do that? That's actually going to be very easy. It's a single if statement. So you add a new line. You just say if has delivered keys, you return and do nothing. We exit early from this function. So like if this is true, we return and we don't need to do any of that. So that bug has been fixed. Good work, everyone. If you want the project files, all you need to do is just go down to the link in the description and just download the files. If you felt lost watching this video, then like in the first video, everything will become much more clear. Like if you watch the first one and then come back here if you are now feeling lost. So yes, that's all. I hope you all enjoyed it. I hope you all learned a lot. Please tell me in the comments what do you think or what do you want to see next. And remember, I am making Amira like a game on Steam. Please go ahead and wishlist the game on Steam. Sure, it's not made in Godot, but you know, you need to finish the existing projects first. So yeah, it's an existing project. Like I actually spent 7 years making Amira, and it was initially a stealth-based game. So please go ahead and add it to your wish list. Of course, now it's no longer a stealth game, sadly. But yeah, that's something else. And yeah, I actually spent 7 years making it, and you can watch a devlog where I explained what I went through throughout these 7 years. And yeah, please watch it and add it to your wish list. That's all for today. I hope you all learned a lot and have a nice day.